All right, welcome everybody to Standing for Truth. My name is Donny Budinsky, and I am your host and moderator for tonight's event on the age of the Earth. I have TRock with me, who will be giving a presentation answering the question, what is the true age of the Earth? Then we are going to follow up with TRock's presentation on the topic of the age of the Earth with an open mic challenge to anybody who would like to join. And it's great to see people in the audience, a good mix of viewpoints on this issue. In many ways, this is a warm up or training, TRock, my brother, for your upcoming two debates. So we got one here, you and another skeptical guy. So you guys are going to be debating the same general topic, age of the Earth showdown, old or young. And then we've got your main event also in May with Conspiracy Cats. So both of you, seasoned, experienced debaters, Conspiracy Cats knows his stuff, and TRock, you know your stuff. So this should be fun. I'm pumped for it. We've been in talks for this one for a while, as a matter of fact. So this one will be, is radiometric dating compatible with a young Earth? And so again, tonight, age of the Earth. What is the true age of the Earth? Presentation by TRock, followed by an open mic challenge or audience questions. So depending on who joins or who doesn't join, we will also be taking some audience questions, challenges, objections, criticism. So during TRock's roughly 45-minute presentation, if there is a question that you have, then feel free to tag me. Or if you're a creationist who has a question for TRock that you'd like to ask him live here in the studio, feel free to join as well. TRock, my brother, firstly, it's great to have you back. Secondly, I hope you've been well. And thirdly, can you tell us just a little bit about yourself for anybody who's unfamiliar with you?
Hi, good evening, everybody. Thanks for hosting, Donnie. Appreciate the opportunity to present and defend biblical history. Um, my personal position, and real quick, to be clear, I was actually prepared for a debate tonight, not a presentation, but we
Right.
decided to do the presentation in lieu of the debate needing to be canceled until a future date, which is fine. But having said that, my personal position is that the age of the Earth is about 6,000 years, plus or minus about 200, maybe 250. Some you'll see some variation in that among young Earth creationists. Some might go out to 10 or 12,000 years, but I personally do not, for a couple of reasons. One is that the biblical text doesn't really support it. And the other one is that the scientific evidence doesn't really support it either. So I'm tightly constrained to a very narrow age for the Earth. My educational background is engineering and manufacturing. My career background is also in engineering and manufacturing, and I like to put cause and effect together to kind of deduce what the evidence in the Earth can tell us about the age of the Earth. So that's kind of where I'm going to be focusing tonight.
Very good. One thing I appreciate about you, TRock, is your extensive study into these topics. Your presentations are always technical and comprehensive. Certainly not your first rodeo or your first open mic presentation. I think going back 6 months, we did one on the fossil record and then your specific model of the flood. And that one was a lot of fun. If people haven't yet seen that, I definitely recommend they check it out. And so, okay, so again, anybody who is just joining us, we're going to be handing it over to TRock for a presentation on the topic of the age of the Earth. And then during that period, I can gather questions. I will also post the StreamYard link in the live chat. I'll pin it. And so anybody who wants to join, feel free to click it. And what we'll do, we'll make it more formal. So if anybody wants to challenge TRock in anything that he says, we're going to go one at a time. Keep it cordial, keep it professional. So with that, TRock, why don't we hand it over to you, brother, and we can get right into your presentation.
Okay, let me share my screen. And I'll be honest with you, I'm not sure if I should hit share system audio or not.
I wouldn't if
Okay.
you're not playing anything that would have audio.
Okay. I'll leave it like that then.
I think I see it loading up at the bottom. As that completely loads, I will let everybody know this one's set in stone. So we do have our next 2-in-1 debate event, Endgame. What is the evidence for evolution? This is going to be May 1st. So again, May 1st, formal debate followed by an open mic. With that, TRock, I see your slides here. And so you're good to go. Take your time. I'm looking forward to this.
Okay, my audio's still checking out.
Sounds great.
Okay, thank you. Okay, good evening again, everybody. Thank you for joining. I deem this to be a very important conversation defending biblical history. And so this is about the age of the earth with science and evidence. I want to point out biblical text is evidence. A lot of critics will say that you cannot use the Bible as evidence, but anything written in history is considered evidence in the real world. So the Bible absolutely counts as evidence, but our focus is not going to be the biblical text because we actually refute the scientific um, opinions that are presented to us in mainstream literature pertaining to origins of the earth. So I'm going to give this as a very brief overview. In the Bible, the age of the earth, as I said, is about 6,000 years, plus or minus a couple hundred years. The first 1,656 come from the first several chapters of Genesis, where you can count the genealogies directly and come up with exactly 1,656 years. I take that to be an exact number, not a plus or minus anything. And then the remaining 3,500 years or so come from the patriarchs, the sojourn in and outside of Israel, the land occupation, historic events, king reigns, so on and so forth through Malachi. I failed to put in here part of that 3,500 years. It should actually be that number's not quite right. Should actually be 4,500 years. But 2,000 years, of course, comes from the time of Christ until now. So you get roughly 4,000 years from Genesis to the end of Malachi, and then an additional 2,000 years from the end of the New Testament until now. So with that, I'm going to jump into the science side of it. In science, there are a number of methods that can be used to estimate time. And the heading here says conflicting lines of evidence. But all I'm doing is listing a bunch of different methods here. I've got about 20 here. Radiometric dating, of course, is the primary one for indicating the absolute age of the Earth. Then there's the other popular methods like carbon-14, ice cores, varves, oxygen isotopes, and then a whole slew of others. I won't read the whole list, but in there I do want to point out one of them is historical reference, mainly pointing to archaeology. And then there's a number of other ones that you can use. Some of my favorite have to do with like the magnetic field decay, population growth rates, a favorite of mine. Lunar recession is another one of my favorites. But anyway, this list here does not, it's not all inclusive, doesn't cover all the different methods out there that could be used. In order to come up with any particular method, all you need is a rate and per unit time, and then how many occurrences that event happened, and you can produce a hypothetical amount of time that has passed. So with that, age determinations, calibration of dating methods. What is calibration? Well, calibration is just a fancy way of saying you want to compare your measuring device against a known standard. And that's the key right there. That's the key, the crux of this entire debate is what is the known standard to which you're going to compare any of your results to, regardless of what the method is. So how do you check or verify your results? Are the results repeatable? What is the calibration standard? Are you doing interpolation or extrapolation? Do you know your initial conditions? Is your rate constant or is it variable? Well, I'm going to back up for just a minute and take note of this particular list. And the one thing that stands out probably the most is just about the only constant rate on here has to do with radiometric dating. And carbon-14, as I've indicated here, is a special case of radiometric dating. It's different in that it's typically only performed on biological remnants, and it's actually carbon-14 is replenished in the atmosphere in real time, whereas the other dating methods do not actually fit either one of those scenarios. But when you start looking at these, couple that stand out: lunar recession rate. It's a constant rate, but it's non-linear, which is fine. So it may be kind of special case compared to the other methods listed here. Magnetic field decay is hypothetically constant. The problem is that you can have disruptions in the rate by reason of reversals and some other things. You can speed up and slow down the rate, so it's definitely not constant in that sense. None of these others, thermal dissipation, population growth, ocean salinity, dendrochronology, mutation rates, starlight, none of, well, starlight might be a place where you could make an argument for, but anyway, the vast majority of these do not have constant rates associated with them, so they make for very difficult dating methods. So with that, the age of the Earth in its absolute sense is primarily and almost exclusively determined by radiometric methods, as far as trying to put as far as trying to put an actual number on it. As we'll find out, though, even radiometric dating is not a standalone method. So moving on, we've got a bunch of questions here to try and answer about how you determine the age of the Earth. One of the things that really stands out in my mind is that the passage of time cannot be measured directly in inanimate material. There is no way to measure time directly. The only way to measure the passage of time is through observation. I'm going to have to give me 1 second. I've got somebody knocking at the door, and I apologize. Give me just a second, and I will be right back.
Looks like I got back just in time with a fresh coffee, ready for a good open mic. So before TRock starts, Doki Doki, I appreciate it, brother. Test those mics after TRock's comprehensive presentation here. For those who are critics, for those in the chat that have any issue or objections or criticisms or challenges to what TRock is saying, we will give you the opportunity to engage and interact with TRock directly. So TRock, if you're good to go again, the floor is yours, brother.
Has my feed been coming through okay?
Yes. Yeah. Looks good.
Okay. Okay, good. I apologize. Somebody locked my front door and I did not know it. Okay, so where were we? We've got a number of questions here that need to be answered. And so any particular method could potentially have a different answer for some of these. But I want to show this thing about this idea of interpolation versus extrapolation. So here, all I've done, it's real generic. It's just the demonstration here is that when you're extrapolating in particular, and you have a formula, a mathematic formula that you think describes the nature of the way things work in physics, if you're off just a little bit, what you see here is if you imagine this as the horizontal axis as the passage of time, over here at the beginning, it looks like they're in total agreement. Two different approaches look like they're in total agreement. But the further you get away from there, the bigger and the bigger the error becomes. And you don't have a way in deep time to validate whether that's the case or not. So what do you do in the secular approach to determining the age of the Earth? Well, all you can do is compare it to other methods, but then every method is subject to the same exact problem. So what you end up with is a complete lack of reference, historic reference, in order to check your results once you get outside of anything that's been actually witnessed in human history. So oddly enough, I'll make this one particular somewhat of a bold statement, because you won't hear this very often. And a lot of you have probably never heard this before, but the older the Earth is, the more impossible it is to determine what its true age is. So once you get outside of human history, and if the Earth hypothetically did have some ancient age to it that well predated human history, you have nothing to check it against, and everything you try to do to perform tests and stuff like that, you're not only have you lost your reference frame for checking, you, the passage of time itself scrambles the physical evidence and makes it more and more difficult to get reliable results that can actually are actually meaningful and can tell you something. And so it's the process of time that makes measuring time very difficult. And this is true fast forward all the way to present day in forensics. Forensic scientists want to jump on the evidence as quickly as they possibly can because it's their best chance to resolution. They do not want a lot of time to pass before they start investigating a crime scene or any of the physical evidence. And so this graph essentially demonstrates why, because the further you go, the more likely you are to try and arrive at some sort of model that approaches reality, but you can't, because the more time that passes, the further off you're going to be, no matter how fine-tuned you think you are. So here's a scenario that I find pretty interesting. There's a volcanic eruption. You date it using something like potassium argon. You come up with an age. Doesn't matter what that age is. 1.4 billion, a million years is a acceptable age range for potassium argon. But then later you find a piece of charred wood in the lava flow, and you date it using carbon-14. There's an obvious problem now. Carbon-14 can't date back 1.4 million years, where potassium argon can. But if you find a piece of charred wood, it is pretty much a given that you will find carbon-14 in it. Now, which one of them do you believe? Do you believe the carbon-14 age, or do you believe the potassium argon age? You honestly, even in the scientific community, you can see the confusion and the uncertainty in the language in the papers that are written. They would not know. Later, if you find a historic report on that eruption, now you've got yet a different age assignment. Which one of them was ever correct? Anybody in their right mind would immediately identify that the historic report was probably the one you need to go with, and you need to ignore the carbon-14 date, and you need to ignore the potassium argon date. And so this is why I said, when you have a plethora of dating methods that you're trying to make sense out of, and you want to use them in any appropriate setting, anytime you do have different methods that can cross over to the same date, they frequently do conflict with each other. And I know that somebody's going to stand up and say, no, these dating methods agree, but we're going to talk about why it is that might be the case, but in reality is not. Back to our conflicting lines of evidence. There's only one fixed reference frame. There's only one, and it's the historical reference frame. You would want to think about it kind of like doing your algebra homework in high school. You work out a problem, you come up with an answer, but you don't know if your answer is right or not. You want to go ask the teacher, did I get the answer right, yes or no? The teacher knows the answer. They can tell you directly whether you were correct or not. That's essentially what a historic reference frame is for calibrating methods, particularly things like carbon-14. So if you have like an archaeological dig site and you find, for example, some old pottery or say some remnants of some cloth or something like that, you can carbon-14 date it and you can come up with an answer, but you don't know if your answer is right until you've compared it to a correct archaeological context. And if the archaeological context disagrees with your results, guess which one changes? That's right. The one that used a quote unquote scientific dating method is the one that's going to be adjusted. And indeed, that's how calibration curves are developed. In part, they are developed through historical dating of known reference points. And archaeology is a great way to compare results of dating methods in a number of scenarios. And in all instances, the the scientists that are using these methods will defer to the archaeological rendering, not the scientific estimation based on one of these methods. Okay. So having said all that, for the sake of the debate, one of the things that I wanted to point to when we're looking at the age of the Earth and the evidence is that when we look at the geologic column, there's some ominous things that stand out. And one of them is that there is only one continental basement, and it's largely made of granite. And so that in and of itself is a huge problem for deep time. What it alludes to directly is that there is no rock cycle. If there were a rock cycle, those granites would have been turned to rhyolite, and they would not come back as granites again. And so we've got this one continental crust. It's the only one that's ever been there. It's busted up very badly. It's been dislocated by a couple thousand miles from its original position, and it's got nothing but sediment on top of it. And well, sediment, igneous rock and stuff like that. But the igneous rock is primarily the result of mantle material melting crustal material and then breaking through in the form of a liquid lava flow. But this in and of itself is highly problematic for the deep time paradigm, because they would have us believe that there's a rock cycle that keeps bringing material back and pushing it back up on top of the continent. I made the statement earlier that deep time actually destroys the physical evidence that you would use to determine that time. It scrambles it really badly, and this is one of those cases where that's absolutely the case, because if there were such a rock cycle, essentially what you would be doing is homogenizing the materials that are available into the crust, and eventually it would be homogenized to the point where there was only one material left coming up. It would have a particular weathering property, and it would go back and it would recycle back up essentially as the same thing, and nothing of the sort is evident in any of the rock layers. So taking a look at some of the strata, what we're looking for is evidence of the passage of time in rock strata. If we can find the passage of deep time in the rock strata, then the young Earth position cannot be true. Conversely, if you cannot find the passage of time, of deep time in the rock strata, something is seriously wrong. It doesn't in and of itself refute the ancient age of the Earth, but it does tell you that something is incredibly wrong with the paradigm that has been put forth. And so when I look at like Grand Canyon strata here, I'm going to zoom in a little bit here. You can see the unbelievably parallel nature of the strata in very wide sheets laid out. This is indicative of water flow, and one of the things about that is the contact points between the layers is very sharp and transitions from one rock type to another very distinctly in a very sharp contact point, which signals not the passage of time. It signals a very rapid process that followed whatever it laid down the first layer. The very next layer came in behind it very quickly. What would you see if deep time actually had expired? And by deep time, even in this case, even 1,000 years is way too much. There's no evidence whatsoever of even 1,000 years passing between each layer, because if such time had passed, you should see no longer sharp contacts. You should see weathering, erosion, very planar, non-flat contact surfaces that are very irregular in shape. And there are some places you can see some incisions and some places where for instance, rock breaking or folding may have happened, but it's obvious that that's what happened. It was a break or a fold, or a very short duration but relatively large scale erosion might have cut through from something like water runoff. And then so you have retreat, and then you have a new wave of sediment being brought in on top of that to fill it back in. But even in those incisions and places like that, you still do not see the weathering between the contact surfaces, or the erosion or bioturbation, or a number of signs that should be present had any significant time passed at all. And so backing up over here, I want to look at this for a minute. This came from a critic actually pointed me to the website that I got this from, trying to demonstrate to me that we can tell by looking at these rock units that they're very ancient. And so I went to look at it, at the physical evidence in this published paper here, and you see the reference to it right here, Upper Pennsylvanian cyclotherms of the Illinois basin in the USA. So what you're seeing here, there's a little key here that tells you what each one of the graphics represent. The dark seams are coal, X's underneath it is clay, and then you have shale, siltstone, sandstone, limestone, that sort of thing. I've highlighted this little area here because what you have is what's called lensing, where you've got different types of sediment or deposits that are tucked into each other, kind of like the shape of a lens in a pair of glasses, where it kind of starts out thick and tapers down thin. And so that's exactly what you see here. And as it turns out, the one that I've highlighted here is actually limestone, which is a marine sediment with coal seam lensed into it. And so it looks like, how do you get the coal in there? The conventional story is that the coal is there because of a swamp condition, but it is literally overlying limestone and overlain by limestone directly on top of it. And the lensing itself is actually a clue that no time has passed, no significant amount of time has passed. What's happened is two different waves came in and probably kind of stitched together this condition almost simultaneously. And so you see this in a couple places down here. Even further down, you see coal seam broken, another coal seam adjacent to it, but it's surrounded by sandstone. And so then you have to ask yourself, how did the sandstone come in the fashion that they're describing here, while interstitching coal, and the other one that looks like they're trying to, the lines are really small, but it looks like they've got shale on top of it. But anyway, it's all water transport sediment, and it's lensed together. So you cannot see, part of the point here is that you cannot see the passage of time, of deep time, apparent anywhere in the rock record. Here's some more examples of how layers basically demonstrate that no time is passing. This is all a matter of fluid flow in very short periods of time. Chalk in North America, you can see the striations through the chalk. There's a color band there that's got kind of a very abrupt transition between a lighter color and then this kind of dingy rust orange color, and then more light color on top of it. This other one, the Navajo sandstone, you can see the waves that just kind of follow all over the place, very much like waves of water. Somebody might argue that these are sand wind-blown deposits, but this is not what you would get. You would not get layering that thick in wind-blown deposits, and there is a very good physics reason for that. It has to do with the density of air and the ease of which you can change the direction of the wind. But here, this looks more like mass flow together uniformly without abrupt changes that occur in wind. Wind transitions very quickly going across terrain, where water with significant momentum does not change that easily. And so this is indicative of water flow, not wind deposition. Here you have the Permian sandstone and Colorado Plateau. You can see the sharp breaks from one to the other. There's, again, zero evidence of the passage of deep time there. Here's the White Cliffs of Dover. If you zoom in on that a little bit, but the thing that really stands out here is that it's on the coastline, and it's still there, and it's very homogeneous, almost pure chalk. It's got some dirtiness to it naturally, but it's so much just chalk. And chalk is kind of a soft rock. Um, it's a biogenetic material, but it's kind of soft, and erosion alone should have obliterated that over deep time. To me, erosion is one of the best arguments against the passage of time in the rock record, because things like this just should not exist over the course of 1 million years, let alone 500 million or 4.5 billion years. Water would just devastate that entire coastline, and it would just be underwater and would not be visible anymore. Here's another one of my favorite things of late to talk about when we talk about the age of the Earth and the passage of time. The one on the left is called Blue Spring, Missouri, and the one on the right is called Big Spring, Missouri. And I put a few little metrics here that go along with them. Blue Spring, Missouri, I've actually been to this site and visited it myself. It's beautiful. The picture doesn't do it justice. The water is blue. It's got some bauxite or something, and aluminum ore in the water that makes it that color, but it's very, very pretty. And it's a kind of a deep spring. It says here 120 feet deep, 87 million gallons per day coming out of this. Now, I did some calculations on this to see what makes sense in terms of how long this thing has been pouring out 87 million gallons per day. Well, I can't tell you what the secularists think about the age of this particular spring, but what I can tell you is you have to have had a recent geological event, relative recent to deep time, in order to justify that this thing is still pouring out 87 million gallons per day. This is perfectly consistent with a young Earth. One of the things that I did was said, okay, at that rate, how many years would it take for this spring to pour out the volume of the United States as it sets above sea level? And it's quite a long time, because 87 million gallons per day, it actually takes several. It takes, I don't remember the exact number, but it probably takes on the order of tens to hundreds of millions of years to replicate the volume of the U.S. above sea level. But having said that, there are a bunch of these springs across the United States, and these two are only 2 of 6 of the largest springs in Missouri. But you can see here, there are over 4,400 springs in Missouri. This other one, Big Spring, I've not been to, 286 million gallons per day. It's about 3 times the rate of the other one. And then there are 4 others that are smaller than these two. And then there are 4,400 estimated different springs pouring out different volumes. And we haven't even begun to talk about drilling into the earth for the sake of well water. Big cities tend to dig deep wells in high volume places to pull water out of the earth. That can't happen indefinitely. That puts a stamp on the age of the earth. And I can't tell you exactly what that stamp is, but it's well under 4.5 billion years, and it's well under 100 million years. And so I find the expulsion of fresh water from inside the continental crust to be a very strong evidence against an ancient Earth, but perfectly consistent with a catastrophic event that happened about 4,400 years ago. Erosion, another one of my favorite talking points. Eroding coastlines. Here, I've got 2 different examples where a team of civil engineers apparently thought it was a good idea to build a highway right next to the beach. It would be beautiful. You can shore it up real well. You can do all these things. You can make a place you can see all the houses in the background of the one, but you can also see what erosion has done to them. Being on the coast, this is actually quite common. Coastlines being destroyed by erosion. Coastal erosion is very different than top-down surface erosion, in that in a lot of places it doesn't even rain very much. You don't have a lot of water, but the coastline, of course, is always exposed to water and the movement of the ocean. And the level of the ocean doesn't really go down so that the coastline is preserved in some way. it's usually very static over long periods of time, or in some cases it can go up and down some, but nothing the evolutionists want to make an argument with, because those periods of time supposedly take very long, or they're very long periods of time, which doesn't help the coastline at all. And so when you look at this and you see what's happened to the blacktop, to the soil base that the engineers put underneath the highway, and what's happened to them, and you go back and compare to the White Cliffs of Dover, you kind of get the sense intuitively, without being a geologist, without being a civil engineer, just common sense tells you that that coastline can only suffer one fate, and that is to be eroded away. And so here, to me, this is a very graphic example of how that happens in very short periods of time. Um, how many years between the time that road was built and the time it got to this condition, I don't know, but I know it's well under. My proposed age of the Earth, 6,000 years, and so it's nowhere close to the proposed age of the Earth from the secular camp at 4.5 billion years. This erosion happened very, very quickly. So with that, I'm kind of at the end of this part of the presentation. I didn't really get to put any more slides than that together, but I will go ahead and show you a few other things that I put together some time ago that I find very interesting. Talk about lunar recession for a minute. Here's the math that's done to determine the recession rate of and the position over time of the moon. And what I did was I came over here and I kind of graphed what this looked like. This is what you're seeing on the graph is the passage of time from present day and the distance that the Earth is. Now, I've got this set here in kilometers, 384,000 kilometers from the Earth today. And as you drag the clock backwards in time, due to the exponential nature of the gravitational attraction between the Earth and the moon, what happens is you're pulling it in at what actually seems like a very slow rate, because out to here, you're at 400 million years, and you've not actually closed the gap that much. But go out another 400 million years, and it still doesn't seem like it's that much. But what happens is you get too close, and all of a sudden it just dives in a very short period of time down here at the end. And so lunar recession puts an absolute maximum, and it's being very generous, puts an absolute maximum of about 1.47 billion years on the age of the Earth, even though we're told it's 4.5 billion years old. Lunar recession says otherwise. There is nothing that would substantially change the rate at which the moon recedes away from the Earth. So if there were a reliable way to double check yourself, this is one very reliable way to double check the history of the Earth, whether it's young or whether it's very, very ancient, like they tell us it is. I'm also done. There's some, let's see if I can find this real quick. Magnetic field decay. So going forward and backward in time, magnetic field decay puts a really, really, really tight constraint on the Earth. So when some YEC proponents offer up 10 or 12,000 years, I'm saying by magnetic decay, that cannot be the case. You cannot get out to 10 or 12,000 years, because being as generous as you possibly can, 10,000 years, you're already, what happens here, let's see if I can back this up and show you. So you start out at present time at the current magnetic field strength of 100%, and this is years here, 100 years, but at 100%, 100 years from now, you would be at 95%. 200, you would be at 90. 300, it's 85, and it just keeps dropping. And by the time you get out to about 1,400 years, roughly, you're already at about 50% of the field strength in a mere 1,400 years, which is way, way too fast. The thing about magnetic decay and calculating it is that it actually follows a very similar mathematical formula to radiometric decay. They look almost identical. And electromagnetic theory, if somebody wants to say such and such about the nature of the earth is well understood, electromagnetic theory is very well understood. We build a lot of technology around it. So this type of formula is typically expected to be extremely reliable. In order for it not to be, you have to have some weird event intercede. And I'm well aware that somebody's going to start talking about reversals, but we've got huge problems with that in and of itself. Not the least of which is they don't even have a reversal in recent history to adhere to in order to try and rescue. Their reversals are so far apart that this timeline is so far inside of it that reversals cannot be an explanation for anything in terms of trying to salvage the passage of time with magnetic decay. So 1400 years, you're at 50%. That means if I go down another 1400 years here to about here, now we're close to 25%. We're already in just a mere 2500 years. We're already at a quarter of the original strength. Do it again from 2800 down to about 3200 or so, and or sorry, 4200. And all of a sudden you're at under 12%. At the time of the flood, which was about 4,400 years ago, you're down to 10%. At 6,000, which is my proposed age of the Earth, you're at 4%. That means that today's strength of the magnetic field, you would estimate to be about 4 or 5% of its original field strength, which is incredibly high and almost difficult to think about. But when you look at that in terms of the proposed secular history, they don't have a reversal, I don't think, any time inside of about a 200,000 years. We can't get that far because here's 9,000 years. You're already at 1%. I get down to 17,000 years. That's not a drop in the bucket compared to the secular history of the Earth. You're already at 0.02% in less than 17,000 years. In my mind, Earth's magnetic field decay puts the tightest constraint on the physical evidence of the age of the Earth. And so it is in direct conflict with almost all of the other dating methods. It even defies lunar recession, because lunar recession is basically just a maximum, but the Earth's magnetic field decay shows that it's irrelevant what that maximum is, because we've got a new maximum and it's much, much tighter than that. So I think I have here a list I wanted to show if I can find it. See if I can find this real quick. Yeah, so here I've got a list of things that put tight constraints on the age of the Earth. Earth's magnetic field, and I've got these listed from the youngest to, or from the shortest to the longest constraints that are out there. Earth's magnetic field, less than 10,000, human population, animal population, helium abundance in zircons, Y chromosome mutation rate, all the way down to planetary magnetic fields in other bodies besides Earth's, all constrain us to 10,000 years or less. And then you have things like the abundance of carbon-14 constrain you to 50,000 or less. Dinosaur soft tissue, 100,000s being awful generous, but that's the way I've put it. Genetic entropy, 200,000. That was based on a discussion that I heard from a geneticist that came up with genetic entropy. I can't remember his name off the top of my head. Erosion rates horizontally, that's coastal erosion, less than 1 million years. Fulgurites, less than 1 million years, so on and so forth. We've got Saturn's rings. Get out here, rate of heat loss from the Earth, 10 million years. Ocean floor sediments, 12 million. Ocean salinity, 62 million. Some of these numbers come from Creation Ministries International and some of their studies. Then you got subduction slab temperatures, faint young sun paradox, methane on Titan, rate of heat loss from Jupiter, lunar recession. And so these two here get us out to roughly 1 billion years at the longest, but we're still way, way under um, the secular assigned age for the Earth. We're not even close to it yet. And so these different dating methods, again, you can see that they're in conflict with each other. They don't always agree. Sometimes um, you can have thousands of years apparent age from one method, right in the middle of millions of years apparent age in a different method. And how do you resolve them? There again, I'm back to the beginning. There is only one way to resolve them. There is only one fixed standard for measuring the passage of time, and that is historical observation. Um, we would be kidding ourselves to think that any scientist who came up with any of these methods or heavily relies on them would not want to actually go back and see the event for themselves to document it and validate that their method is correct. I recommend this particular site. This is creation.com, Age of the Earth, 101 Evidences for a Young Earth and the Universe by Don Batten. It's a really good article. I've only got listed here 32 of the different things that I was interested in talking about. He's got 101 there to investigate. Definitely worth your time in looking into that. So, Donnie, with that, I'm going to wrap it up and turn it back over to you.
Very good, brother. So if somebody were to argue that there is no scientific evidence for a young Earth, specifically an Earth under 10,000 years, they'd be wrong in light of what you've just presented.
They would be yes, they would be absolutely wrong. I like to remind the critics that you don't have different evidence. You have the exact same evidence that we have. It's in the interpretation, but what we're doing here when we have these discussions is we're saying, look, we're willing to entertain this quote unquote purely scientific discussion and use real world physics. And here's where we actually differ, because they would say something along those same lines. Here's where we differ. We recognize the limitations of writing an equation based on physics and trying to use that to determine time. And the reason we recognize that limitation is because of the conflicts that are out there. So the evidence is there. It's how do you want to evaluate
it? One question, I have many questions. You presented a lot of great stuff, but we do have critics backstage, so I think they're probably going to bring up a lot of the same stuff I would. But I am curious on the decaying magnetic field. Secularists will say that the magnetic poles flip every 200,000 or 300,000 years. And so they look to these reversals. And so it never completely decays away. If you could speak to that, what are your thoughts on that? Is it just a rescue mechanism? Is there any legitimacy to that? What are your thoughts on it, TRock?
Yeah, no, it's a great question. It's interesting because I kind of struggled for a while on how do you refute such a claim with reversals, and then it dawned on me there's a legitimate physics problem with such a claim. I kind of highlighted it whenever I was going through the magnetic reversals and showing how short of a timeline you destroy the magnetic field so fast. And they're, like you said, 200,000 to 300,000 years for a reversal. There's two problems. One of them is the amount of time between reversals, and the other one is if you and to be clear, not all creationists accept that reversals happen on a global scale. I think Dr. Kent Hovind is one that rejects those. Personally, I'm somewhat on the fence. I'm okay with accepting them. I know physicists like Dr. Russell Humphreys doesn't seem to have a problem with them in concept. But I have a little bit of a problem. But to get back to your actual question, the problem is if reversals happen, they're very much like, let's say you have a light bulb hooked up to a battery with an on and off switch. A reversal is like flipping that switch off and on. The problem is that the more you do it, the faster you drain the battery, which is exactly what would happen to the Earth's magnetic reservoir. The mantle is made of solid rock, and there's an iron core below it. And I presume that the iron core contains the majority of the field strength. But the two problems here are that heat destroys magnetism. You can do this any kind of real-time experiment. You can get an iron magnet. As soon as you get it hot, the Gauss strength, field strength of the magnet starts dropping because of the heat. And so a hot Earth for 200,000 years, it's way too long for the reversals. And when they do come, all they do is weaken the field even more. You can temporarily spike part of the field strength. So there's what they call a dipole and a non-dipole. The dipole is what you think of a normal magnet with a north and south. Non-dipole typically means there's like going to be either 4 or 8 different polar directions that the magnet has vectors in. And you can temporarily increase the field strength of the non-dipole portion, but you're going to decrease the dipole portion in doing that. And the majority of the field strength as we measure it today is actually in the dipole. So yeah, have a reversal, get a temporary increase in field strength, but it's going to be followed by a rapid decline. And it only happened and it primarily happened in the non-dipole portion, which is a very small portion of the total magnetic field anyway.
Yeah, you mentioned Dr. Russell Humphreys, and from my understanding, he made a prediction that these reversals could happen due to the mechanisms associated with the Genesis flood. And so when they made those discoveries, I think in 1988, apparently he made the prediction in 1986. And so one could say that's a successful prediction. And I've read Dr. Russell Humphreys argues that the Genesis flood and young Earth creation best explain what we observe in the decaying magnetic field. Do you have any thoughts on that, TRock?
Yeah, yeah, that's a great question. I've heard his talk and read some of his information on it, and he makes some good points. Of course, he's a physicist, and I'm not. But I'm from basic material science. What I would get from his interpretation is that a reversal would happen specifically because of the mass of a continent sliding across the crust and putting friction against the crust and the mantle below the continent, and perhaps that can drive reversals, and so that reversal is going to be proportional to the speed of the movement of the continent, right? If the continent moves too slow, you're probably not going to get a reversal out of it. And so in that sense, you pretty much have to move the continent quickly in order to see apparent reversals. And another reason behind that is the amount of friction that has to be produced in order for the ocean floor and any of the igneous or the magmatic based rock to actually become liquid enough to reveal those reversals. You have to have a certain amount of friction there, and the secular science community actually does not have a valid mechanism for it, but it does have to happen quickly.
All right, very good. TRock, what I'll do is start bringing people in rather than me hog all the possible objections or questions. And so we got a mix of creationists and evolutionists in the backstage. So let's do this. What I'd like to do is keep things organized. And so rather than being a free for all, like we sometimes do with our open mics, we're going to have a couple on deck with one person directly engaging. Now, with the creationists, I assume it's going to be a question or two rather than an impromptu debate. And so Andrew was the first in line, but why don't we start with Brian from Apologetics 101, as you may have a question or two on TRock's presentation or the age of the Earth, and then we'll move to Andrew for some impromptu discussion or debate with TRock. So Brian, you're up. Andrew, you're going to be on deck. Then we'll go Tolkienomics, my fellow Lord of the Rings fan, and then we'll go Doc. So Brian, great to have you. How you doing, brother? And what's your question?
Doing awesome. Hey, TRock, I was interested on what you said about archaeology. But you said something about archaeology being able to be used to prove the age of the Earth. How so on that?
No, that's not what I said. I didn't say you
What
use
is it?
archaeology to prove the age of the Earth. What I said was it's a way of measuring the passage of time.
Okay.
You refer back to archaeological sites, and understanding that part of it is tracking civilization development and that sort of thing. So if you can, relate the Greek Empire to the Roman Empire to the Byzantine Empire and so on and so forth, you can kind of connect the dots, follow the portions of the written history that actually tells you durations and events and things like that. And so you can use archaeology to produce timestamps.
All right. I was just curious about that because I heard you say that, and I like archaeology, so I was wondering, how exactly did you factor in archaeology into your arguments?
Well, you can though you can factor in archaeology in general because what you're going to find is there is no written history or civilization history that goes back more than about 5,000 years, even in the secular paradigm. And so, knowing that and knowing that the early civilizations sprang up with extremely advanced technology, that kind of puts a timestamp on how old the Earth must be and how old the human population must be.
Okay.
The Bible itself, of course, being part of that, because it was exactly archaeology that uncovered a whole bunch of the copies that we have that make up our modern Bible.
All right. All right. I think I had a question on the Earth's magnetic field weakening, but I can't remember it. But go ahead to the next one. That was the only one I had. If I can think of a question, I'll get back with you later.
Brian,
Let
did
me
you
ask you
want
something.
Oh,
Sorry, I was
T-Rock,
just
go
going to
ahead.
ask Brian real quick, and it's kind of a question for everybody to think
Okay.
about. Um, Brian, what's your favorite evidence for a young Earth? Understanding that you might put the Bible at the top, but in terms of the scientific evidence, what do you think your favorite evidence for a young Earth is?
I like C14 in diamonds. It's so hard for people to dispute it.
Yeah, same
um,
here. Same here.
uh,
That's one of my faves.
What's a good response to those that say nearby nuclear material could recharge the C14 in the diamonds deep within the earth?
That's an incredibly weak argument. I live in Oklahoma. I'm from Arkansas. I've been to the diamond mines. The diamonds come up to the surface of the earth. Um, they're telling us that those they call them a volcanic pipe that brings the diamonds up to the surface of the earth, but they're telling us that the pipe itself erupted over a million years ago, very very long time ago. So the diamonds are no longer found in the core of the earth where this alleged I don't know what they call it, the neutron bombardment theory or whatever. They're nowhere near any of that. They're up in the same horizon as where you would carbon date anything, without batting an eye, and it doesn't have that effect on those things at all.
Brian, did you want to give your new series a shout out? I know you put out a new trailer and you have some upcoming episodes.
yeah.
Yeah, go ahead.
Yes. Yes. Uh, Actually, my wife is calling for me, and she doesn't know I'm on here. So,
Uh-oh, you're in trouble, Brian.
yeah, I'll be right back. Okay.
Yeah, you take your time. No rush.
All right.
Okay, I got one question, then we're going to bring in Andrew, and then we'll have Tolkienomics on deck. So, T-Rock, a common objection I see has to do with the Egyptian chronology. Apparently, the Egyptians go back further than what we would say the flood, when the flood took place. And so the critics will kind of scoff and say, oh, wow, the Egyptians or even the Chinese, they were thriving in terms of civilization while the worldwide flood was going on. Do you have any thoughts on that?
Yeah, archaeology's never been a deep focus of mine, but I did spend some time and try to understand some of that and kind of try and get my head around some of those arguments and some of the methods in determining the age of an Egyptian civilization, for example. Couple of key things really stand out there, and that is that both the Chinese and the Egyptians actually have a wide-scale flood built into their history. One of the interesting things that I found a long time ago, and it's been, you'll have to forgive me, it's been a while, but there's a website out there called solvinglight.com, I think is the name of it. And their focus on their main page is more on Greek history than it is Egyptian history. But one of the things that they point out there is that Noah is actually a character in very ancient Greek history. And not only Noah, but Nimrod, Adam, Eve, Seth, the granddaughter of Noah. There are several characters that are they're actually characters in those ancient mythologies. So whenever I learned that, I went back and real quick, just to give you an example of how they're connecting these. Poseidon. Do you know who Poseidon is? Anybody?
Oh yeah, he's the Greek. Yeah,
the Greek god of the sea, right?
mm-hmm.
That is actually Noah. And so you can go back and look at ancient Greek art, and I'm talking about the very ancient stuff. The Greek mythology got, changed considerably over hundreds and thousands of years, but the very ancient stuff, Poseidon is actually Noah. And the way they depict him is he's on a boat and he has his scepter, and then you have Hercules, as it were. Nimrod is vying for control over, basically to usurp and take Noah's position, or Poseidon if you're in the Greek. And so they depict them several times where Hercules is trying to wrest control from Poseidon. What they're actually describing is Nimrod trying to take control from Noah in Noah's later life, down towards the end of his life. He lived 350 years after the flood. So, being the patriarchal society that they were, pretty much everybody on the planet deferred to his authority. But at some point, he gets too old to become a leadership figure, and eventually he'll die, and somebody's going to take his place, right? And so that was Nimrod. There's a whole other discussion we can get into in as it pertains to dinosaurs and extinction along those lines. But back to your original question about the argument, what you find is that all of those histories have a strong tie that very, very closely mirrors the biblical history. And so now it becomes a question of the timeline. How do you know the Egyptians lived before the time of the flood? Well, now you're back to secular dating methods, some of which I've listed there. The further you go back in history, the scanter the evidence available is. And the other point that I tried to make very clear, the more time that passes, the more difficult it is to estimate the amount of time. But one of the things that they're doing is they're trying to use what is known unreliable history. The Manetho history, it's not even firsthand, and it's got a bunch of exaggerated king's reigns and stuff like that, and doesn't consider any of it to overlap. And so they're relying on unreliable information to make an argument against the time of Noah's flood and put those civilizations before that. I find it very unconvincing, to say the least.
Do you think the mighty men of renown, those in the pre-flood world that we read about in Genesis 6, do you think those famous or well-known leaders or people of the pre-flood world inspired a lot of the mythological stories and heroes we read about today in terms of Greek mythology, Norse mythology?
I'll give you my honest opinion is no, they did not, and it's largely theological, but part of it is when Noah and his sons and their wives and everybody boarded the ark, and then there was a global flood. They did not bring any of the Earth's history with them other than what was recorded in the first several chapters. And I think that was intentional. I think it's not outside the realm of possibility that they were instructed by the Lord himself not to talk about the happenings on the earth before their time, other than the basic written stuff that we have. And to further kind of put a exclamation on why I don't think those characters have anything to do with Greek mythology and some of the other mythologies, is because I think what they're actually doing, what's his name, Dr. Doug Petrovic does some fantastic work on Egyptology. And one of the things he shows is that Noah's name is actually in Egyptian history. And a lot of these names that you read about, they're actually derived from biblical names, and they are directly tied to the characters we do know about that were post flood, which include, of course, the sons of Noah and some of their early sons, from which the nations, a lot of the nations were named from them. And a lot of that mythological history is developed from those same characters. And the few that we do know about that we can connect pre-flood are the ones like Adam, Eve, and Seth. But they don't really have very many names that you can connect anywhere else.
Very good, TRock. I appreciate that, brother. And so what we'll do is allow Brian to give his new series a shout out. I appreciate it. And then Andrew is going to bring the heat and spice things up for us. No, but seriously, Andrew, we're looking forward to having you engage TRock. Brian, go ahead, brother.
Yes, thanks. It's actually not a series. It's just another episode of my other series I had, Duncan's Controversy, Gap versus Ungap. That's going to be airing Monday. I do have a question real quick before I go. Something that TRock brought up. Have you heard of issues involved? Some people bring up like the dating methods of Egyptians and things like that. Have you? I heard there's problems with the chronology concerning Egyptian dating methods. Have you heard of something like that or familiar with it? The arguments there.
Well, I know a little bit about it. I spoke on it just a second ago in response to Donnie's question. I can tell you that the chronologies that are put together in secular archaeology, they're derived from known unreliable sources. So if they read that such and such kings existed and so on and so forth, that trace you back in time to when a particular Egyptian dynasty existed, they're based on, like I said, non-eyewitness history as recorded by somebody like Manetho, who was just a historian. He was not present for most or all of the history that he recorded. And then it's known that they're, even among the secularists, it's not, this isn't a conspiracy theory kind of thing. The secularists understand that there are conflicts in some of Manetho's history, and so they know it's unreliable. So what happens, you can kind of see the evidence of this uncertainty built into things. Like, for instance, there was some big controversy over when Joshua camped about the city, and I apologize, the city that he marched around 7 times. Do you remember
Jericho.
the name of this? Yeah, Jericho. Thank you. Where Jericho was destroyed, the secularists tried to put that date well before the actual time of the city of Jericho. And how they arrived at their date was some of their spurious methods. Well, fast forward some years later, and they found some new evidence that overturned their previous ideas, and they found out, oh wait, Nineveh or Jericho really probably did exist during the time that the Bible said. And anyway, examples like that are kind of ubiquitous in trying to trace Egyptian and other types of ancient civilization histories. They're constantly having to change their answers.
All right.
All
Thank
right.
you. I appreciate that. I'm going to go get me some supper and I'll be right back.
All right. You've earned yourself a good dinner there, Brian. May 1st, we got another open mic showdown. So hopefully we'll see you there, Brian, and also looking forward to your next episode of your series this Monday. Okay. Andrew, great to have you here for this open mic on the age of the earth. So Andrew, how you doing? And what would you like to discuss with TRock?
Yeah, thanks for having me on. Is my audio sounding okay so far?
Sounds great.
Okay, cool. Yeah, so I actually had a few things that I hopefully can address with TRock here regarding his presentation. First thing I would just like to clarify real quick. I missed a portion of it as I was joining the stream. He was talking about, or you were talking about something, TRock, about the rock cycle and how supposedly that would homogenize the sediments around the world to a certain extent that they'd all be the same. I didn't really understand that point. Can you elaborate on that for a quick minute?
Sure. Isostatic rebound is what we're told explains why we still have land above sea level. And so the idea of the rock cycle, and you can correct me if I'm wrong on this, but the idea of the rock cycle is that you weather and erode material from the top of the continent. It generally makes its way towards the coast, and then in subduction zones, it gets pushed back up underneath the continent. But in doing so, as you remove mass from the top of the continent, isostatic rebound helps bring it back up to some extent, and the convection of the plate motion and convection help recycle the material back into recreating continental crust. Right? Is that
Yeah, that's one pathway in the rock cycle, sure. Yeah. So I guess what's your issue there? Because I'm having trouble understanding. Yeah.
So my argument is that we have a granitic crust,
Right.
and there's only one, and there's only evidence of ever having been one continental crust for any particular continent on the planet. And it's topped with marine sediment and water transported sediment. So what's supposed to happen in this rock cycle? You're supposed to rinse this stuff off back into the ocean, pull it back under, put it through some heat, and push it back up. But why would we still have granite? Why wouldn't everything be turned to more of an igneous mix?
Well, granite is part of the continental crust, so it doesn't subduct. It's
So it
lighter and less dense than oceanic crust.
Well, then how do you get the sediments that did subduct back on top of the continent?
Are you talking about marine sedimentary packages that are already on the continent? Because those come from either actually a lot of different ways. So there are, of course, changes in sea level where the continents can get partially submerged underwater, and so you get marine sediments laid down in certain zones that way, especially in certain sedimentary basins that are below sea level at that point. But also some of those sedimentary packages can get they're part of what's called an accretionary wedge. So basically, as continents or certain plates are colliding, some of the sediments literally get sort of plowed on top of pre-existing continental crust. So there's multiple pathways you can get marine sediments on top of the continents without having to subduct them.
So I'll tell you what a younger skeptic told me here very recently, and you can tell me if you agree with this. He was basically saying, okay, there is evidence of an inland sea on top of the United States, for example, right?
Yes, the Western Interior Seaway.
Okay, the
yes,
Western Interior
Cretaceous in age.
And so I was pointing out some of these same arguments. That's actually the conversation where I got one of those slides showing the coal seams lensing into limestone. But one of the things that he said that I was honestly a little bit dumbfounded by, he said there wasn't just one global flood in the history of the Earth. There were many global floods. What do you think about that?
Well, I think I know who you're talking about. I think he was exaggerating there in the sense that there have been global changes in sea level multiple times in the past. I wouldn't consider those like the same as a Noachian deluge in the biblical sense. But yeah, sea level has changed many times in the past, and that has changed the sediments on the continents.
Personally, I got the impression he didn't mean literally a global flood with 100% inundation. He was really just saying multiple very large scale floods on various continents. I think that's kind of the way I.
Well, yeah, he was talking about marine transgressions is the technical term for it.
Sure, but you know, the topic
Which,
of discussion,
by the way, also explains part of what you were talking about. This is the other thing I wanted to cover, which was the coal seams interlaid in the limestone, and you were talking about how they're thicker in some places and horizontally thin out as you move along the coal seam. So two things to remember here. One, of course, is what we were just talking about, transgressions, which we're talking about Carboniferous age deposits here, where the eastern side of North America, for example, like you were talking about, were basically covered by river floodplain type fluvial deltaic environments. And of course, intersplayed between those were swamps where coal, where the peat that became coal was accumulating. And so along the coast there, these kinds of environments, there would be these transgressive sea level events where sea level, of course, would rise. That would submerge part of these basins where the coal was accumulating, and limestone would be, and other marine sediments would be laid down there because sea level was gradually inundating those parts of the continent. So that I don't see it as particularly problematic for the conventional geological standpoint.
So interestingly, Andrew, a lot of what you said, I don't have a reason to disagree with. But the topic of the discussion is about the passage of time here. And so whenever I pulled up that example from the Illinois Basin, I'm literally looking for evidence of the passage of time between those, what you called fluvial events and marine transgression and so on and so forth. Where is the evidence of the passage of time between those?
Well, in other places, for example, you can see there are certain I forget what the exact sequence is. It's either from sandstone to or shale to sandstone to limestone, or the reverse, depending on if it's a transgression or a regression. But you can take a vertical sequence at that particular location. So obviously offshore, you're going to get limestones, you're going to get shales, because those are the depositional environments where those sediments are laid down. Then further inshore environments, like a kind of beach setting, you'd get sandstones, and you'd get more coarse-grained rock types further inland, that's sort of. So yeah, you can look at a vertical sequence and you can tell whether it's a transgression or a regression. So that's one way you can see that. Or like what you were talking about there with that was the other thing I wanted to mention, was these coal seams being thicker in some places and horizontally or laterally thinning out. Like you can tell that rock formations, as they occur laterally, are not all of the same age. So obviously the rock unit in spot A is not necessarily the same age, even if it's a uniform rock formation, as spot B. You kind of have to like look at the signs of whether a transgression occurred there, if that makes sense. So it can get quite complicated. So
let me ask you a question real quick.
Okay.
As you understand the young Earth model, how long was the Earth inundated with water?
Well, I've heard various models where it's been completely submerged, where there's been tectonic activity where parts of it were partially or even not submerged and then became submerged back and forth. Like I've heard multiple models, and some seem to conflict with what Scripture says. Others just conflict with what the geological evidence says. So I've seen a lot of them.
Well, the reason I ask is because if you take a strict reading of the Bible in order to determine, whether something somebody like myself says makes sense or not out of their own model, if you just take a strict reading of the Bible, what you find out is that, we'll call it day zero, the day the flood started, there were a total of 150 days of inundation described. And very shortly after that, you start seeing signs of regression of the water off the continents, the receding phase.
Sure, that's my understanding.
And so what that tells me, just putting cause and effect together, is that the maximum time any particular square inch of land was underwater was 1 year. But the minimum time could have been as short as a couple weeks to about a month, maybe 6 weeks. So parts of the Earth were not fully inundated for the entire year. But what that brings me back to is the actual wave motion and the kinetics of a global flood, because you were describing the some of the things that are named in secular geology in the Illinois basin, and you were talking about fluvial, you can say river channels and deltas and
Yes.
and swamp areas and stuff like that, right? Plus marine transgression and that sort of thing. But personally, I find it incredible that most skeptics don't understand that these are natural occurring events in a 1 year global flood. You have to have a recession stage with
In what
channelized flow.
experimental setup or in what context exactly? Because when we look at modern floods or even past floods, they don't look like that. So in that sense, how can you call it a flood event? Would be my
Well,
question.
I've heard this argument before. I've several people say, but we have floods we can see today. That's essentially what you're saying, and none of them do that. And that's essentially what you're saying, right? Your problem is scale. You've got the scale completely wrong, because what
How
I'm trying
does
to
the larger scale of a flood change its physical characteristics? Like the laws of physics and chemistry aren't going to change depending on water depth. And we can also measure the water depth for that measure, but that's completely separate topic.
so I mean, it's a fair question, but part of what you can see just by very plain daily observation, without being a geologist or a physicist of any kind, you can just walk out and you can look at different types of creeks and rivers, and the scale absolutely does matter. In a very deep river, you can see that the body of water tends to flow in a slow, deep river. The water tends to flow in much more laminar fashion, in basically meaning straight line sheets, kind of like what you see in the Grand Canyon rock strata. But in a shallow creek, where the topography is changing rapidly, the water is deeper in relation to the obstructions that are in the path of the water, you get much more turbidity, right? Well,
Right, but understand that's within a single depositional environment. That's a fluvial setting. That's not the same thing as what you're talking about, which is basically tsunami type waves slowly inundating the continents.
that's
Right?
your kind of hasty generalization is kind of what you're doing there, because what I'm trying to develop for you is the sense that the water has to start at sea level. It has to slowly over time come up. There are waves coming in, there are waves coming out. So there is inundation and recession happening during the inundation as a whole. The 150-day cycle has a whole bunch of mini inundation and recession cycles inside of that. And then once you get to once you get towards the peak of full inundation, if you have land anywhere near the surface of the water and another wave is able to come off the top, you can still have these periods where you're mainly getting runoff and you're going to get some channelized flow temporarily. And then you can have another inundation event where more waves bring water in again. And so you completely change the dynamics again, but you're cycling back and forth through just about every conceivable type of fluid flow imaginable in water and sediment. You're cycling through all of them back and forth. It's not all one and then all of another. It's not all of one and nothing else. It's a cycle of back and forth where land is continually getting swept and then recedes and swept and recedes, and it happens in different scales in different places. Plus,
Okay,
you have the east.
Just real quick, what's producing that kind of fluctuation exactly? What mechanism is producing that?
That's a great question. Part of it's erosion. I mean, if one wave erodes a bunch of sediment away, the next wave doesn't have the same type of topography to deal with, does it? But then you've also got the movement of the continent itself. There's a generally kind of a northwest drift of the continent. Well, I'm speaking from the perspective of North America or in the United States, but it's got kind of a northwest trajectory that it's been on. And
Sure.
the leading edge has been piling up from plate collision and from rolling under some of the debris, some of the sedimentary debris that was out in front of it. So that's why the western half of the U.S. is up at a much higher elevation than the eastern half is.
So just something I'd like to clarify here is, so you're talking about these fluctuating patterns of rapidly inundating and regression and so on and so forth. So was there ever a time, according to you, where the entire earth, as described in the Bible, was completely submerged by water?
Yeah. In short answer, yes.
Okay, so how come then we still have subaerial exposures throughout the geologic column, even up to the what most people would consider post-flood layers, or layers that are late into the flood?
Okay, so post-flood subaerial weathering, I believe, is what you're referring to, right?
Subaerial exposure. It's not underwater. It's exposed at some point. That sort of thing.
So, a couple points there to consider. One of them is just because the secular geologists tell us that the particular soils or paleosols, I believe, is what you're referring to. Just because
Not even talking about paleosols here.
So, what type of rock unit are you talking about?
Well, there are a lot of types. There are like mud cracks. There are raindrop impressions. There's karst dissolution in limestone that forms caves. You can't have that during a worldwide flood because the rainwater that forms that obviously wouldn't penetrate the limestone if it was submerged by a mile of water. So there are a lot of features that indicate subaerial exposure, and we see them throughout the geologic record.
Pick one that you want to talk about, though.
Okay, how about raindrop impressions?
Okay, so, I mean, just using some basic common sense and cause and effect. If there's a global flood and everything's 100% inundated and you have raindrops exposed, there's a couple different ways to do that, right? There's not just one mechanism, but I want to highlight one point real quick. The 100% full inundation, that was one of my points earlier, is the couple weeks, 4 weeks, 6 weeks minimum inundation, that's at that point, right? So then once you start receding, one of the things that you're going to have is continued erosion, because you're going to start breaking down into more channelized flow and that sort of thing, and you're going to end up with actual mud deposits on top. And so how do you even fossilize a raindrop? I mean, how does that even happen in anybody's world, whether you're a proponent for deep time or not?
Secular explanation is that you have semi-cohesive sediment. So kind of think like semi-wet, semi-dry cement, basically. Mm-hmm. You have raindrops falling on top of them. Afterward, so it leaves those little circular dents that are the raindrop impressions. The sediment then hardens slightly, so you have to have the sediment hardening and preserving those raindrops without anything else getting laid on top of it. Because like you were saying there, if you had this water runoff from the flood after the continents were fully submerged, you would get these raindrop impressions or even sediments laid on top of them. You would get them completely wiped clean. Basically, you need an extended period of time, longer than the flood time scale, for these types of impressions to be preserved, basically, before other layers get laid on top of them. That's a secular explanation. So I don't see how that, or like trackways, for example, which are basically the same kind of mechanism, how that could be explained during flood runoff, or even as it's inundating the continents.
So let me point out, first of all, most of what you said, I don't have a reason to disagree with. So
Okay.
you're not distinguishing between deep time and a young Earth in saying those things. If you have
Right, but I'm distinguishing between a secular and a flood geology-based perspective. Am I not?
No. Why can't you have such a scenario in a flood? The only thing that you said. The only thing that you said that even hinted in that is that you had to have a certain amount of time for the full lithification of the sediments, right?
And you have to have semi-cohesive sediments that these impressions are laid in. So they can't be fully saturated with water, as would be the case if they were just partially or even fully inundated after the flood submerged the continents, basically. And you can't have other sediments being laid on top of them, because those would basically wipe them clean, because we know how abrasive different kinds of sediments are, like sand, think sandpaper. Like you can't have rapidly successive layers like being proposed in flood geology and also have things like raindrop impressions and trackways and footprints and stuff like that.
Okay, I like to think of it kind of like this. You kind of alluded to an idea that I identified here a while back about unwarranted assumptions in sedimentation. And so the way I like to think about it for the average person that's not a geologist or doesn't do physics or anything, think of a cement truck. Whenever somebody wants to pour the foundation for a new building and they haul in the cement trucks, they basically take their dry cement mix, put water in it, and then they stir it constantly, and they keep water mixed into it to the point that it's you have easy fluid flow from the cement mix, right? The only way to do that is if you have a lot of water in it.
Sure.
And it sounds to me like you're kind of equating that type of sedimentation to something very similar to pouring a cement foundation.
Equating what with that kind of cement?
Essentially, the ratio of mix between water and sediment.
Right, but are we talking about the secular or the flood geology perspective being conflated here?
What I'm saying is, in the secular perspective, you think, and every time I've heard anybody talk about this, they kind of say words that are very similar to yours that kind of allude to this same basic unwarranted assumption. Every time you describe sedimentation, it sounds like you're describing a very wet slurry that is put down, and then it's like if you put your foot on it, it's so wet that you're just going to sink into it.
Why is that unwarranted?
It's unwarranted because the fluid dynamics in a global scale flood do not necessitate that your sediment water mix is anything like a cement truck.
How do you get semi-cohesive sediment that's partially dry under a giant flood event? The sediment is going to be saturated with water.
That's what I'm trying to tell you.
How do you get separation like that?
They don't have to be saturated the way you're saying they do, because one of the things that can happen is...
No, I'm not saying they have to be saturated. I'm saying the opposite. I'm saying, how do you get them unsaturated? How do you get this partial drying of the sediments in a flood event.
I know what you're saying. You're essentially saying it both ways. Same thing, two different ways. You're saying
Okay.
it had to have been saturated. How do I get it unsaturated?
Yes.
Right.
During a flood event.
That's
during a global flood event.
That's what I'm trying to explain to you.
Okay.
What you have in a cement truck is a mixing operation. In flood dynamics, that it basically it equates to turbidity flow, because all you're doing is mixing. The whole point of the mixing truck is to keep the water saturated through the sediment.
Sure.
In a flood, you've got a different kinetic condition where it's much more like a centrifuge. If the construction guy caused the cement to be poured in a much drier state, he would probably rather do that, but he knows it's not possible because you can't get the smooth lay, you can't get it poured down uniformly. There's a whole bunch of problems associated with the setting of the cement and everything else. You can't do that, but in nature you don't have that constraint, and what you have instead is much more like a centrifuge, where you're basically and don't take this the wrong way because somebody will try and twist what I'm saying, but you're basically slamming the sediment out of the water. You're forcing it out quickly so that the water separates and gets above the sediment and runs off. And that has to do with both the nature of the fluid flow and what I described as a centrifuge, where your heavy particles are supposed to fall out faster so that the lighter particles are left on top, which is the water.
Okay, so you're basically talking about a hydrologic sorting type process there, in a sense, or
Andrew,
based on the density and size of grains, right?
It's been my experience. You have to be very, very careful when you throw out a phrase like hydrological sorting, because I
okay, so
not,
yeah, that's why I was trying to clarify.
I would not tell you that for example, the order of the fossil record is due to hydrological sorting. I wouldn't tell you that.
No, I wasn't even talking. I was talking about the grain sizes, the sorting of,
sure.
like you were talking
I'm
about.
Just pointing out that you have to be careful with. You have to be very careful with how you use that phrase, hydrological sorting. So,
okay.
in a sense, hydrological sorting always has to apply in some sense if the water is moving, but it does not have to produce the exact same result, and that's dependent on how the water is moving.
Right. So the only thing I wanted to clarify there was, are you saying yes or no that coarser sediments here are going to be laid down below finer sediments in terms of grain size?
Not necessarily.
From this fluid flow.
That's what I was trying to emphasize, is that I don't want to hand wave or generalize what hydrological sorting is, because you can get a variety of results depending on how the water is moving, what type of sediment is present. Some of the factors involved are how fast is the water moving, how far did it have to move, what are the fluid friction interfaces between the sediment and the boundary condition underneath it. There's a whole bunch of factors in there that can drastically change the results you get.
Okay, so how does this relate to what you were talking about, this kind of centrifuge where the water is sorted out in a sense from the sediment itself? How does that happen physically?
Well, in a global flood, if you have a sprinting continent, this is kind of an important part of the whole thing, is and right or wrong, it would still be an important part of understanding. How do you explain what the results are? Did the continent sprint? Yes or no? If you answer yes, then basically what you're saying is, if it sprinted during the inundation phase specifically, not before or after, but during the inundation phase, now you can have waveforms coming over the land for two different reasons. One of them, at least two different reasons. One of them is just the normal motion you would get, like if you put your hand in a pool of water and just waved it parallel to the surface and watch the water flow over the top of your hand. You don't need seismic activity, but if you implement seismic activity of any type, Now you can literally lift the water in a much more vertical fashion. And when you do that, you can also lift sediment with it in a vertical fashion, which means you can also set it down in a vertical fashion. And so there can be a much more vertical component to the inundation than horizontal in some cases.
Right, but we're talking about experimental setups where it's basically a flume tank where you're doing this essentially.
Sure.
Where here we're
Okay.
talking about miles or at least dozens, hundreds of feet of sediment. There's not really a clear connection between the two. Like
Well,
you have to provide your calculations, your evidence that this can be extrapolated to this.
Well, so first of all, I'll go back to what I already said earlier. You've still got a problem of scale that you haven't recognized. If you set up a set up a flume experiment of any kind, how deep and how wide is your flume trough going to be?
Well, it depends on the experiment, but I'm asking, how do you go from, or I'm not disputing the varying depths on that scale of the flume experiments, or even on the scale of a normal river type setting, for example. What you're describing is something we've never observed in those cases where the entire continent is being inundated. We actually do have a few cases of parts of the continents being submerged with water, and not just these types of transgressive events like major floods moving across large regions of the continents, and they don't produce any of the features that you're talking about here. They like you said, produce erosive channels, potholes in the sediments. Basically, they don't produce these neatly stacked type layers, and then all the water comes out of the layers, so to speak. Like you need to provide a mechanism, a physical mechanism of demonstrating this type of process, which you haven't done with these tanks.
So, Andrew, if I'm hearing what you're saying correctly, you're saying that we have seen some larger scale continental marine transgression. Yes?
No, it's not a transgressive event. It's an actual flood sweeping across large parts of the continent.
By where's the water coming from?
Well, in many cases, it's coming from glacial lakes that are being dammed by something. And once the dam breaks, the water just floods across the continent.
So you're kind of making my point for me. You're not comparing apples to apples. In a dam breach of any kind, there's been a number of them, whether it's a glacial lake or a man-made dam. There's been a number of dam breaches with large scale flooding ensuing afterwards. You're not even remotely comparing two events that are similar to each other, nor are they supposed to be. One of the things that you're missing in the dam breach example that you're giving is you don't have a sprinting continent. The other thing you're missing is you don't have submarine seismic activity happening at the same time. So if you take limestone, for example, you may remember me going back and forth with Erica here a while back on limestone on the continents, and she made some unwarranted assumptions and basically assumed I was saying something I wasn't saying. But my whole point there was that if the limestone is out in the ocean before the flood starts, all you're really doing is moving the limestone from the ocean floor to the continent. You cannot do that sort of thing with a dam breach. You have to have a moving continent, and you have to have some amount of seismic activity to go along with it.
Well, that's my point. We have physical evidence for these kinds of dam breaches happening, whereas you're talking about something no one has ever observed that you can't produce in a flume tank, for example. So those experiments go out the window because they're not applicable to, like you said, these scale events. So what is your physical evidence that this sort of thing can even happen?
I've already described a bunch of it. How do you get 1,000-foot thick limestone formation on top of a granite crust? How do you get it there?
I already explained how you get it through marine transgressions and subsiding parts of the continent, for example. Like as you deposit more and more sediments over that region, the layers underneath it are going to sag. So it's going to be increasing weight over that part of the continent. So that entire region is going to subside vertically. And so you can get even more accommodation space for more sediments and so on and so forth.
So you're back to Gutsick Gibbons' argument about a very calm sea where and so you're saying
no, I never mentioned a calm sea at all. That subsiding parts of the continents happen all over the place in different kinds of conditions.
The problem with what you're trying to argue against the global flood is you're still not showing the timeline, and you're still telling me almost the same mechanisms that I'm telling you.
How is
it's the whole purpose of this conversation to get us back on track was, where is the evidence of this passage of time that we should say the earth is billions of years old? It's not in the limestone.
Well, some types of limestone do require large time scales to settle out. Not all of them, obviously, but
now you're back to the very calm. Now you're back to the very calm sea on top of a continent, but you're also in your paradigm. You're going to tell us it was not a global flood condition. It was the Western Interior Seaway kind of condition, but there was land available somewhere very nearby.
Yes, on both sides of it.
And what I'm saying is calm seas and very slow precipitation of limestone out of a very calm sea close to a shoreline and deep time do not go together.
How so?
It is a physically impossible condition.
How so?
Because as the moon passes back and forth, we have underwater ocean currents all across the globe now. We have global currents. We have global air currents. We have a moon that doesn't follow a very strict planar path as it relates to the position of the Earth. It goes back and forth all over the place. It drags the tide with it. When you get up close to the coastline and you wind the clock back in deep time, you've got too much gravitational influence from the moon to keep a sea calm that close to the land.
So here's the issue I have with that, is that limestone today, lime muds are accumulating in very shallow water. So if you were like, if there was a major disturbance there, like not even the moon or just like huge ocean waves there, which are in fact occurring, you wouldn't, according to you, you shouldn't be getting these accumulations of limestone, but you are. So clearly this doesn't have much of an effect once you get to deeper water.
No, because now you're conflating. If you have a specific example where this is happening, I'd love for you to share it with me. But
the Bahama
what
Banks.
Say again?
The Bahama Banks.
The Bahamas? The Bahamas? Yes. I've been to the Bahamas. What I'm saying specifically is deep time. So if you see a place like the Bahama Banks where it's settled down and the ocean is relatively calm, it's not all the time around there. I know it's not.
I know it's not calm. That's a wave-based environment, but that's that's actually part of my argument here.
But if you've seen sediments accumulating in any fashion like you're describing in that environment in your lifetime, you haven't begun to touch the effects of deep time on that same thing.
Why not? You're saying you can't your argument here is you can't for some reason extrapolate that far back, but you haven't given any good reason why you can't, like especially when we have evidence for like intermittent events in between the layers.
So I did actually Andrew. In my presentation, I showed at the 200 million, at the 400 million year mark, so on and so forth, at the 800 million year mark, I showed the relative position of the moon to the Earth. If you extrapolate that back, well, the tidal forces increase exponentially as the moon gets closer.
We're right, but we're not talking about lunar recession here. We're talking about sediment accumulation.
Yeah, but you have to have a moon 400 million years ago, and it has to have a tidal effect. And it has to, in your worldview, that condition has to have existed and waned over time for a continuous 400 million years to get the moon to the position it's in today. And what I'm saying is, whatever sedimentation rate you see today is not indicative of what you would expect when the moon's closer 400 million years ago.
Why not? Because the tides would somehow be exponentially stronger.
That's part of it, yes.
Or what?
It's also
and
because
how do you know
rates,
that tides that strong would not lay down sediments at all?
Because
what's your evidence for that?
Erosion rates are too high. They're too high today. That's why I showed the photos that I did of coastlines eroding.
How are you getting erosion underwater from tides? How are you getting erosion underwater from tides at the surface?
You're asking the question backwards. We have Bahama Islands today land above water. And part of my argument is, if you dial the clock back 400 million years, you cannot have land above water anymore because you eroded it all away.
No, hold on. Our original conversation was how you could get thick deposits of limestone in this kind of interior seaway type of environment. You were saying, your argument, if I understand it correctly, is basically the moon, according to the secular perspective, was closer to the Earth. The tides would have been much stronger, and so these muds basically would have been kicked up and they couldn't be deposited. Right?
Well, they can settle somewhere, yes.
Right, but you're saying they couldn't have been deposited near the shore, right? Because the tides would have been too strong.
There would be no shore. That's part of the point, is there would be no shore. If you have tidal energy too high, you have no shoreline after a few million years.
Okay,
but can you deposit? But can you strictly deposit in that scenario? Sure, you can. It's gravity. It's density. Of course, you can deposit things in the environment.
I don't know what we were arguing about then. Okay.
But where are you getting the lime from?
Well, what kind of limestone are we talking about?
You brought up the Bahamas.
Okay, so oolitic limestone. So we have marine algae and kind of planktonic organisms. Well, certain parts of the banks. It can vary depending on which part of the bank you're talking about, where the waves are going back and forth, and this limey mud material is basically being rolled up into these sand-sized spheres that we call ooloids. So that's where oolitic comes from. Mm-hmm. The name comes from. So yeah, that's limestone can form in different conditions.
Okay, so correct me if I'm wrong, but the lime itself, the secular paradigm, the secular version of limestone existence is that it is biogenic material, mostly, right? Not entirely, but mostly biogenic. Most of it,
right? Yeah. Well, marine limestone, at least, yeah, for the most part.
So, are you calling the formations around the Bahamas biogenic?
Yes, they are biogenic.
They are, and how do you know they're biogenic?
Because you can see the planktonic organism settling out today and being rolled around by all that material being rolled around by the waves. You can see it form.
Okay, so let's clarify a few things though. Lime is calcium carbonate, no?
Yes.
Or lime is composed of calcium carbonate. Which one's
more
accurate?
That's all I mean by limey mud here is calcium carbonate mud-sized particles.
Okay, but clarify real quick. Lime is composed of calcium carbonate. Is that accurate?
Yes.
But it's not entirely calcium carbonate. Is that accurate?
Well, if you're talking about lime that we use to build things, then no. But what we're talking about here is mainly calcium carbonate.
We're talking about naturally occurring limestone that you go
Yes.
back to pre-lithification. It is not pure calcium carbonate, correct?
Well, most of it is. It can depend on the rock unit you're talking about. Like, yeah, there can be some siliclastic material in there too, but sometimes for some formations like chalk beds, there isn't.
But what were you talking about? Plankton? You were talking about what's it called?
Yeah, or just calcareous algae, kind of just dying and
photoplankton. Is that the word you used?
Yeah, plankton, or they're like not even other kinds of organisms that don't live in the water column. They live actually on the ocean bed, and they're calcareous. They produce calcium carbonate.
Okay, but photoplankton, for example, photoplankton
Okay.
in and of itself is not pure calcium carbonate, is it?
No, but their shells are for the most.
Right.
Yeah. And that's what's being deposited.
My whole point is that when you identify something as being biogenic limestone, I get the distinct impression that you're saying all of the calcium carbonate itself, CaCO3 molecules in that limestone, were produced from a biogenic source. Is that accurate or no?
They weren't produced by the organism. The organism secretes calcium carbonate from the surrounding seawater around itself to produce a shell, and once it dies, that shell is then becomes the limestone.
I don't mean produced as in like an excrement. I just mean that it came from the bodies of a biogenic source. Is that accurate?
Well, then no, not in that case either. It didn't come from the organism. It's just
you
being
said their bodies
from
you said their bodies decompose.
It's being extracted from the seawater to build those shells. So there's calcium carbonate ions floating through the seawater around the world. These organisms are taking that and using that to build their shells, and then when they die, their shells fall to the bottom. That forms the limestone.
I understand we're not saying two different things here, and I'm not trying to imply anything weird. I'm just asking you to clarify.
Okay, well, your language sounded different, but okay.
If I have a cubic centimeter of limestone, are you telling me that 100% of the calcium carbonate molecules have been through some sort of biogenic process before they got there?
Well, part of the matrix there isn't biogenic, but I don't see what your point is here.
Well, my point is, how do you know whether the bulk of the calcium carbonate that makes up the limestone, how do you know whether the bulk of it is actually biogenic or not? And it sounds like you're having a hard time telling me.
You can look at it under the microscope and see the shells there, so you know if the shells where the.
I know you can. That's not the defining factor, though. The defining factor is not the presence of the photoplankton shells or any other type of marine organism. That's not the defining factor. The defining factor is the calcium carbonate molecules themselves. They're not shells anymore. They're calcium carbonate molecules
that are in these micro shells in the limestone.
But you've already said that you know that this calcium carbonate molecule is suspended in seawater.
Yes, and it is taken up as the shell of the organism while it is alive and then deposited after it dies.
I understand. That's
so
easy.
So
There's
what are we worrying about here?
My whole
gentlemen, I'm going to jump in real quick. Excellent discussion. I love the free-flowing nature of it. Maybe we should do a minute or two more to kind of wrap things up. Again, It's been a great discussion, but since we just hit the 2-hour mark, I thought it might be a good idea to move to Tolkienomics and then Doc.
Yeah.
Okay, good enough.
Okay,
Real quick,
go
let
ahead.
me ask this to fulfill Donnie's request. Let me ask Andrew to kind of zero in and show us where the passage of time is in the rock record.
Or just looking at a specific rock formation here, or just in general, or
Pick your example.
well, you can look at, for example, off the top of my head, coal seams like the that you were talking about earlier. The underlying peat that forms the coal seams after you have lots of heat and pressure, which we obviously agree can form rapidly. You can just have a lot of heat and pressure there. The plant debris that has to accumulate there, like I know there are ideas of floating forests basically, but that wouldn't produce enough material quickly enough to form these coal seams, especially when they alternate and you have multiple coal seams in succession. So I guess that's one point here, is that you have to have a lot of plant debris to begin with, and then have it compressed into these centimeter to meter thick coal seams, and then you have like sandstone, for example, above that, and then you have another coal seam and shale above that, and sandstone, and then another coal seam. So you have cyclothems basically of coal seams. So that'd be one line of evidence.
Donnie, do you want me to respond to that, or do you want to move on?
Why don't we move on? Just to be fair, as time always flies by with these open mics. So Andrew, feel free to stick around. I really enjoyed that technical back and forth.
Yeah, thanks.
But let's give Tolkienomics is a creationist, so possibly you have a question for TRock, and then we will allow Doc and TRock to spar a little bit on the topic of the age of the Earth. And so Tolkienomics, great to have you. How you doing this Saturday night? And did you have a question for TRock?
Yes, thank you for having me. I appreciate you putting this on. Thank you everyone for coming by. You know, it's an interesting conversation, and not everyone can meet eye to eye right away, but there's a lot of information from both sides, which is great. So thank you for presenting those.
My pleasure.
TRock, thank you so much for coming. And you know, I really appreciate that you come from a manufacturing background, because I've always been saying in regards to the radiometric dating conundrum is that we have a tooling and a tolerance problem, and you displayed that excellently today with a lot of the data. Because you know, if we have the wrong tools and they're not giving us the right information, how can we trust what we're saying? But I had some questions about that, and I'm not 100% sure though. I know with rubidium and strontium, or you know, with the potassium, uranium, potassium dating and all that, we have a problem with diffusion. Could you explain a little bit more about how diffusion, sample diffusion into the sample from the environment could offset the dates that we'd be getting, and how frequent that would be?
Diffusion in rubidium strontium kind of method?
Sure. Yes, because I know that a lot of geologists tend to use that as the gold standard for their numbers. So I thought, but I know that when I ask them, they can't really be confident in any errors from diffusion. And I was wondering, you know, how does that happen? How frequent is it? You know that.
I'll be honest with you. What you're describing sounds a little foreign to me. So let me talk about the particular methods that are related to rubidium, strontium, that sort of thing. Typically come from zircons, right?
Sure.
You're aware of that? So
Right.
a zircon is a silicon crystal, basically. So you can think of, like, if you've ever been to a rock shop and seen quartz crystals. Zircons are basically a form of silicon crystal, and they're very hard and very durable. They withstand very high temperatures, actually. And so the secular method is to take the zircon crystals and run them through a mass spectrometer and basically count individual atoms of, in your case, rubidium and strontium. Rubidium's the parent, strontium's the daughter. Now, they're of course going to tell you that the rate of decay is constant. And personally, I do not take issue with that. I will readily grant constant decay throughout the history of the Earth. You'll hear a lot of creationists argue against that assumption. Personally, I do not argue against it. I think if there is any variability to it at all, there's not enough variability to distinguish between an ancient Earth and a very young Earth. I've got a very bipolar presentation here. Either the Earth is 4.5 billion years or it's 6,000 years. It's and nothing in between, really. Nobody's defending such a thing. So anyway, and so when you talk about diffusion in a silicon crystal, there is no diffusion per se. Nothing's going into the crystal or coming out of it. There's helium. Now, helium diffusion, I don't know if that's what you had in mind. Helium diffusion is kind of a separate deal from the radiometric method itself. Were you referring to helium diffusion?
Well, from what I've understood it so far is that in the environment itself, so when you actually go to the dig site and you're collecting the specimens that you're taking to the lab, that the concentration of isotopes in that material might be offset by the environment or the activity or whatever's been going on around it, so that even though you might say that, oh, it has a specific concentration and that leads us to a specific date after testing. It's not necessarily indicative of or accurate because uh, because a material that's right next to it could have absorbed some of some of its aspect, actual, like, literally diffusion in the field itself. So the materials would transferring between two different objects that are next to each other.
Okay, so
Um,
you're saying the environmental factors alone can change the concentration of the elements.
right.
Okay, so to answer your question, there are two types of actual diffusion that might be relevant. One of them I've said is helium. The other one is argon. Argon's an inert gas, and but so is helium. They're both inert gases, and they're able to diffuse. Helium, because it's such a small molecule, and because it's inert, it can literally slip between other molecules in a given rock sample. Um, Potassium and argon. Now, argon is a little bit different. It's a much heavier molecule, and I can't remember. I've got the periodic table here beside me. Yeah, it's what I remembered. Argon has a molecular weight of about 40, so it's way higher than helium. It's about 10 times higher than helium, but it still can diffuse out because of environmental factors. So yes, argon diffusion absolutely can obscure radiometric results if your method is potassium argon. But if you're talking rubidium strontium, there is no type of diffusion in that sense that would extract any of the isotopes out of the crystal. There's a completely different problem associated with rubidium strontium dating and try to use it to establish absolute ages, but it doesn't have anything to do with diffusion.
Okay, I appreciate that, and I also appreciate you clarifying that it does impact the another type of dating that is also used in the field. So we could definitely X that one out too there. I was asking because I'm curious. Wouldn't Let's say when we look at gemstones and we look at rocks and we see, for example, they come in different polymorphs, pseudo-hexagonal twinning, so on and so forth. Wouldn't that show us that we're looking at vastly different physiochemical conditions around the world, that we can't make temporal inferences from the basic methodologies of absolute positioning and our flawed radiometric dating?
Well, in sort of, yes, you've got a valid point in that. I mean, you use some a bunch of complicated words to say that
I
essentially
collect a
what
lot of
you're
gemstones. Sorry.
That's fine. What you're describing is that, yeah, you've got a range of temperatures and pressures and chemistries available around the globe. Every scenario is slightly different, produces slightly different results. That's why you get differences between like rubies and diamonds. Rubies are a very hard mineral, as well as diamonds, but they're not as hard as diamonds. They've got chemistry in them. It's not present in diamonds. But they probably have some very similar thermal and pressure characteristics in the process that makes them. But the chemistry alone is different, and because the chemistry is different, the cooling rate's different, and so the one thing you can learn about the age of the Earth and diamonds is that besides the carbon-14, that's a really obvious, very strong argument. But besides the carbon-14, diamonds are actually destroyed by heat. So once you have a diamond, if you subject it to very high heat, like what's in the mantle, you're just going to destroy the diamond again and have to start all over. So any diamonds that you do have formed, basically all you know of is their first genesis of creation, and that they exist today. And if you find carbon-14 in them, it couldn't have happened very long ago. But the key point is, whatever process formed diamonds in the earth, it had to do it kind of quickly, and you have to have rapid cooling of the material in order to solidify the diamond. Because if you leave it hot too long, you basically just destroy the diamond again. And if you go to volcanic pipes, you see they always talk about show us the evidence. A volcanic pipe is basically a violent eruption towards the surface, but doesn't break through like a conical volcano does. But you're expecting to reach very high speeds of material shooting from deep in the crust up to the surface, very high speeds. There's nothing slow about that. So I don't know. I hope that answers your question. But yeah, the various chemistries and physical characteristics absolutely demonstrate that you have to have rapid processes for virtually all of them, and any two of them could happen at the same time, and you wouldn't even know it.
Right. Yeah, absolutely. I mean, thank you so much for explaining that, because I've been reading lately that pressure solution activity in subduction zones have been creating, it's essentially create like a potentiating lubricant. Do you think that then that would be even exacerbating further all the subduction activity?
I'll be honest with you, I don't know how to answer that. Um, what they call subduction. I mean, I don't want to take up too much time here. Donnie's on a time
Yeah,
limit
yeah, yeah.
Yeah,
as
let's
well as
make this the
myself.
last question, and
Yeah,
then
sure.
we'll bring in Doc. It's been great.
I'll just suffice it to say, the secular idea of subduction, there's nothing realistic about it. It's a very fabricated idea. I'll just leave it at that.
Tolkienomics, I appreciate it as always, brother.
Thank
Love your
you.
feedback. Great questions. And thanks for joining. Feel free to stick around, of course.
Thanks so much.
My
Appreciate it.
pleasure.
This was awesome.
It's why we do these. It gets us out of our scientific, in this case, echo chambers, and gives those who agree the opportunity to ask clarifying questions, and also gives the skeptics the opportunity to interact with the points and the arguments. And so, Doc, it's great to have you as always. I appreciate your willingness to engage in these open mics and debates. Certainly not your first time here, Doc. You've been here many times. And so, firstly, great to have you. Secondly, how you doing? And thirdly, what would you like to discuss?
Howdy. I'm all right. It's been a little bit since I was last on. Moved, life changes, all that fun stuff.
Very good.
As for what I'd like to talk about, a few things have been touched on already. I think I'll go with TRock. You seem to think that springs represent a problem for an old Earth. Is that right?
Yes.
And just it's been about 2 hours since you last talked about that. Maybe a like a 30-second summary of why you think it's a problem?
Okay, so I just looked at the state of Missouri at one time by itself, and then I also extended and looked at an example out in Utah. Essentially, the volume of water coming up out of the continents is highly consistent with a young Earth, because you don't have to worry about how much water and where it came from so much as you do in a deep time scenario. And what I'm saying is the volume of water coming out of the continents is so high today that it demands some sort of recent geological explanation in order to account for it.
Okay. So, I guess important question here: where does the water that comes from springs come from? Like, where does it originate?
I mean, that's a fair question. I can't say that I definitively know the answer, but I think I can definitively give the two most likely explanations. One of them is that it was under there are large aquifers under the continents from the creation that are partially still there. And the other one is that some of that water could have potentially been subducted during continental movement. Those are my personal two main explanations.
Okay, those are two fair hypotheses, I guess. Let's go with the first one, because other than during creation, that's basically the conventional explanation. Most springs are fed by underground aquifers. Aquifers are layers of rock that can hold and transmit a large volume of water usually on human timescales. Sometimes it can take a few hundred or 1,000 years for water to enter and then exit an aquifer, but I don't see how it's a problem, I guess, because we know how aquifers are fed, we know how they transport water, and how water exits them. We actually exploit a very similar process to make artesian wells. I believe it's some type of well. We basically make a man-made spring. It's not an issue.
Okay. So, backing up a little bit, the way you described aquifer, I think equates to what somebody like me, I grew up in Arkansas. We dug a well by hand. We would probably call what you described as a water table.
You dig through the water table, yes.
You dig down until you hit a water table, and you typically would go below it. But the water table itself, you would think of, if the water were solid, you would think it maybe appears just like some of the strata in the rock, right? Because it's like,
what do you mean if the water were solid?
Well, I'm just saying, freeze it and don't let it flow, and you just look at a cross section of it. You would look at it and see it in kind of thin laminar sheets, just like you do a lot of rock strata. Is that correct? And
as
to be clear,
ice?
no. No, I'm not saying it's ice. I'm just saying, for the sake of
if you were to pause time, it would look like it had sheeting through it.
It would look,
I'm not sure why you think that.
To be clear, I'm well aware that some water in the ground exists in gravels. Some of it exists in open aquifers of whatever irregular, usually shape of an open aquifer. And then some of it exists in, for example, some of it's saturated in clays. Some of it is in thin sheets between rock strata that literally do appear somewhat like the rock strata itself. Right, so there's a variety of circumstances under which you're going to find water in the ground.
I mean, yes, sort of. So maybe just to clear things up a little, there's lots of different types of rock. What we call an aquifer is a layer of rock that transports a large volume of water
Okay.
relative to other rocks.
That's what I wanted you to clarify.
Okay.
That's what I wanted you to clarify because a large section of rock, I mean, gravel can transport large volumes of water. Personally, and it's fine. You use the words the way you know how to use them. It's fine. I'm not going to take issue with that. But personally, I would not use the word aquifer to describe a gravel bed full of water.
Well, I'm sorry, TRock, but gravel it usually makes for pretty good aquifers.
Again, I'm not
depending on
arguing any of that. I'm just saying the word aquifer implies to me open space. But if you're saying it does not
open spaces between the particles and the rock, that's what allows the water to flow. Okay. Gravel is great for it because it's a bunch of big pebbles.
Okay. Again, I'm not trying to argue any of those points. I'm just trying to clarify that the words give different impressions. But what I want to go back to your thing about where does the problem for deep time come from? So, Big Blue Spring, Missouri, the one I said that I've been to, it gives a pretty good example of why it's a problem. So you got this water, and the spring itself is about 120 feet deep, but it's under enormous pressure, and that pressure is being released constantly. And so there's some limit to the amount of time that can have transpired with enough pressure to push the water to the surface and enough volume of water to come to the surface. It's the pressure and the volume limit the amount of time. And what I'm saying is you need some geological event to explain why this aquifer, why this particular spring is still gushing out 87 million gallons per day.
I mean, no, that's not an issue. So when it comes to springs, and I just looked it up, like Blue Spring, water is taken into the aquifer and moves through it. And then if due to factors like erosion, there's a gap in the rock, water is going to preferentially fill that gap because more of it can flow through there. It's under less pressure in an open space as compared to the rock. So water is going to be continuously squeezed out of the rock into the spring so long as water keeps getting fed into the aquifer. And at a certain point, it'll reach an equilibrium. That's what happens with most springs.
You ready for me to respond?
Sure.
Okay. You've given kind of a very generalized idea of why it's not a problem, but you've not really solved the problem. One of the things you said was the water is taken in, but you didn't say how it was taken in.
Okay, so that can happen in several different ways. Water can be introduced from overlying rock layers or exposed rock layers, which usually get it from rain or from contact with a water body like a river or a lake. Water flows through rock very slowly, but it flows through most types of rock. So water starts at one point, moves, and then there's open spaces in the rock now, so more water can flow in, moves through, and this process keeps happening.
So it's
until either the aquifer is full or it finds an outlet, like a spring.
So it's a cycle, basically, that will only terminate whenever pressure reaches equilibrium, is what you're saying.
Even then, it doesn't really terminate. It just stops changing and it becomes more continuous. And yeah, it is a cycle. It's part of the water cycle.
Okay, so you're saying that it can happen indefinitely.
It will continue to happen as long as there is a supply of water.
Okay. So you've got a really obvious physics problem to me, and that is the pressure. Pressure flows from high to low, not low to high. So wherever it is that you get this water from, it has to come from a higher pressure environment than what is being ejected from the spring.
So yes and no. Let me see. Donnie, would you mind sharing my screen in a moment?
Yes.
Okay. Thank you. Let me zoom in here. This is a diagram of a couple different types of aquifers. So they are confined versus unconfined. Now I would have to look more at the geology of this area to say this for certain, but water gets introduced to an aquifer in places called the recharge area. That's where ground is exposed to the air and can get rained on, or water can get introduced through other ways that I've already mentioned. The water percolates through the ground by gravity because water continues to move down as much as it can. Now, what can happen sometimes is one layer of rock will readily accept water, but an overlying layer won't. And when that happens, water continues to get fed in and continues to push down by gravity, and that puts all this water down here under pressure. And since this water is pressurized, if you tap into it, or like if there's an earthquake that cracks this confining rock, water can just spurt up to the surface as a spring or a well. Like I said, this stuff is really well understood because many large cities rely on these processes to get their water. Like I live in Iowa. A lot of cities in Iowa do it, and so do many others throughout the Midwest because there are big aquifers running through the states.
Okay. No, I appreciate the graphic. What you're describing, of course, is basically a principle that's used in modern technology all the time. My local well supply, my local water supply comes from a tower that sits well above my current elevation so that I can benefit from the pressure, the head pressure of its height, right? So you're not describing anything new or novel or unknown to a young earth creationist, but you're also not describing what happens at Blue Springs. I guess what you're going to have to do is show me where such a configuration exists that has anything whatsoever to do with Blue Spring, Missouri.
All right, let me look up the lithology of Blue Springs because it appears to be a tourist destination, so it probably has quite a bit of info on it. Oh, wait, no. Blue Springs, Missouri, not Blue Springs, New Mexico. I think this is the place. Oh, okay. Yeah. Okay. Originates from a limestone, part of an aquifer system. Or wait, it says Floridan? Are there multiple? There are multiple Blue Springs, apparently. That's Florida. Jeez. Okay. Blue Spring, Missouri. But so until I find like the until I find an exact source for this exact area, all I'll say is that this is how springs work and it's understood very well. It's not a problem.
Fair. Okay, listen, fair enough on finding the specific source for Blue Spring. You've still got a problem pertaining to our topic of discussion today. We've already agreed that there is probably an aquifer somewhere feeding Blue Spring, Missouri. I know that. There has to be. Water isn't coming from thin air. The question that you were answering tonight is on the age of the Earth. How long has such an aquifer existed? How much water did it have? How long will it last? How long could it last? And one of the distinct possibilities here, Doc, is that the continent itself is sitting on a bunch of different aquifers that are all busted up now, but they're sitting on these aquifers, and it's actually the overburden of the continent and the rock units above it that are setting down on these aquifers and pushing the water up to the top. Not necessarily doesn't describe all cases of all springs, but this is a distinct possibility. And if that's true, then the expectation is that over time, the continent is actually settling down, but it's got a stopping point at some place. It's going to stop settling because the water is going to stop being displaced by reason of either rock interference or running out of water, or something's going to happen that the continent quits settling down. The continent settling down can very well explain the pressure needed for the water to come out.
So, if I'm understanding this right, your conception of the surface of the planet is sort of like a waterbed that has someone laying on it, and the waterbed has a leak. That's what I'm getting from this. If I'm wrong, please let me know. What I'm telling you is that this is not a problem for old Earth, because this process will continue as long as there are aquifers that can be recharged. We have historical accounts of springs drying up because, for example, mining operations that took out a bunch of an aquifer. We know that water comes from the surface and it goes through an aquifer because, and this has been a big problem in some areas in recent years, of contamination, like pollution from the surface in the recharge area, making its way through the aquifer to where people need it to drink. So, like, we know that the water comes from the surface. And it recharges and it powers itself because of how the water cycle works. TRock.
You're still not describing
TRock, let me.
Spring at all.
It's a spring. It's how springs work.
No,
now,
we both have already agreed that not all springs work that way.
The vast majority do, even if this specific one is a weird magical aquifer where the water is just springing out from a hole in the ground that has been locked away for however long. This is how most springs work. And to be clear, TRock, what I came on here to discuss was this, and saying it's not a problem for the old Earth. I'm not making a claim on how old the Earth is in this. I'm just saying this isn't a problem you can throw at us.
It actually still is a problem.
No, it isn't. You keep saying it is. You refuse to admit when you're wrong.
Doc, you used mythical characterization of what I said to make your argument, and I find that very telling in and of itself. But the Blue Spring is not some magical reservoir of water that's just coming out for no apparent reason. I never made that argument. You should not default to that type of language to try and make your argument. What I'm saying is, in the case of Blue Spring, if you go look at the local topography, you need water above the location of Blue Spring to account for its flow. Even if it can be described in a continuous cycle where there is some reservoir up above it somewhere that's being fed by rainwater or runoff or anything else, you're going to have to go find it. And I've been through Missouri quite a bit, and no such place exists that is going to feed Blue Spring the way it does. It's setting at the wrong elevation. The local topography is wrong. There is a finite amount of water that is in the reservoir that is feeding it, in the aquifer that's feeding it. There's a finite amount of water. There's no particular realistic mechanism to put it back in. And
there is a realistic mechanism. I've been going over it with you for the past 20 minutes.
You're not describing anything pertaining to this particular spring, and probably not for most of the springs in Missouri, and probably most of them in the U.S. I'm well aware it's a basic physics principle. If you've got water above your exit point, you can keep adding water there. That's nothing in that is in dispute. What I'm saying is,
TRock, pause for a second.
The
T-Rock,
sheer volume
here's what is
coming
going
from
on.
landlocked places that don't have reservoirs above them is enormous.
T-Rock, let me walk you through this. Here's what's going on right now. I'm telling you, hey, this is how springs work. We know how this is how springs work. This is how the majority of springs work. Your response to this is how springs work is, well, you don't know right off the bat if this particular spring right here does the same thing that all other springs do. Do you have any evidence that it doesn't follow what all other springs do?
You just completely mischaracterized my argument again. And you made the positive claim that most springs do this thing that you've got the graphics on the screen for. You've made the argument that most springs do that. I don't think you have the data to support that.
TRock, oh, for crying out loud.
I know. Scientists are supposed to have data. Silly me. Why did I ask such a thing? I'm just telling you.
TRock, believe it or not, I'm not familiar with every single spring in the continental United States.
But you can make a claim that most or all of them operate this way.
Yes, because it's very basic hydrogeology.
No, it's a very basic
follows
physics
the laws of
principle that
physics.
does not necessarily apply to any particular spring.
Hydrogeology follows physics. Water flows through a material and will escape at low pressure zones. You, as a civil engineer, should know this.
I have told you this before. I'm not a civil engineer.
Whatever engineer you are, you should know this.
I've already told you you're describing a physics principle. You're not describing specific occurrences in nature. I know this is possible. I know this is how aquifers are set up for the sake of providing water to communities and stuff like this. There's nothing mystical about this. This does not describe deep time, though, and it does not explain that any particular spring in nature can exist indefinitely, because even if you go out and find me a dozen examples in the next 3 minutes, even if you go find me a dozen examples of springs that are fed exactly this way that occur in nature without any man-made intervention of any kind, you still are not describing deep time, and you still have a deep time problem, because erosion and other geophysical processes will basically destroy these things before any deep time allows to have passed. So show me the deep time that's supposed to be apparent.
I'm reading.
Well, Donnie, I am getting kind of wore out myself. I know you had a time limit.
Okay.
So I would.
Sorry, so I'll share the link with this to you, TRock, but I found a publication on the geology of the area, and their conclusion is that this spring is fed by the surrounding area, notably from streams that end underground, nearby sinkholes, and very porous rock that allow the transmission of large quantities of water. So it's a spring, like I've been telling you.
Okay.
There is for this specific place, like you've been wanting. It's a spring.
I captured your link that you provided, and I will definitely go check that out. But that still does not answer the question of deep time.
Gentlemen,
it answers the question that this isn't a problem, and that was what I came here to say. It's not a problem. Sorry.
Does not answer that question.
All right, gentlemen, another great discussion. We wanted to wrap things up at the 3-hour mark, which we are close to. And I've enjoyed this. I think we had some good banter. We had 2 on the creation side join and 2 on the anti-creation side, Doc and Andrew. So I really enjoyed it, including this last discussion, TRock and Doc. So I am going to remove everybody currently except for TRock and myself. And what we're going to do is wrap it up with our super chats that came in. And I do want to remind anybody who has joined recently, we have a couple more debates, actual formal debates coming up with TRock. One of our main events here, TRock and Conspiracy Cat. So this is going to be a big one. We've been working on this one for a while, and it's happening in May. And so I'm excited. This was kind of a sneak preview into that. What I like about this one is it's going to be focused. So focused on radiometric dating. Is radiometric dating compatible with a young Earth? And then we've also got, which we need to fit into the schedule, TRock and another skeptical guy. So both of those debates coming up. And okay, TRock, couple super chats came in. Great work tonight, brother. I appreciate it. And I appreciate the professional nature of tonight's impromptu debates. Very good. So Alan, $20 super chat. I appreciate the support, Alan. Question for TRock. How much new dirt has to accumulate on Earth to form new layers that can avoid serious erosion? I'm young Earth, however, curious to know what answer you could give to an old Earth scientist.
Unmute. Okay, I've got the question on screen. How much new dirt has to accumulate on Earth to form new layers that can avoid serious erosion? The answer to that question is not really, you can't answer it with a volume. You have to answer it with a rate. How fast does the new dirt have to accumulate to form new layers that can avoid serious erosion? So looking at the hydrological cycle, looking at weathering patterns, that sort of thing, your dirt has to accumulate at a very high rate, much higher than is normal today, much higher than is normal today, because the water cycle is going to guarantee that, the biggest thing to understand about the water cycle is that water is evaporated up in basically a distilled form. So evaporation of the ocean surface, for example, is a very efficient way to get the salt out of the water. And we would use, civil engineers really would use that method if it were convenient. The problem is the scale. But the point becomes that when you get pure water going up and you're not carrying all the dirt with it, that means that when it comes down, its momentum is way too high, and one drop of water is going to displace quite a bit of dirt, and it's only going to displace it in one direction, and that's downhill. So the answer to your question is, what rate do you have to accumulate it? And you have to accumulate it faster than the water cycle in order to build new layers. And so the global flood produces such a mechanism in that actually what happened was apparently the pre-flood ground surface was scrubbed completely off and replaced with marine sediments. So not only did you remove a bunch of dirt, you had to replace it, and possibly more in terms of thickness, but perhaps less in terms of total surface area. But the global flood does that. But you had to have the continent moving in order to do it, or you had to have very high energy waves bringing that sediment up onto the land, and that's the only way you can outpace the water cycle.
Very good, brother. That's why you're the expert at these topics, TRock. I appreciate all the study you do into them. It's a blessing, especially with this ministry, is we have a team of young Earth creationists. It allows me to focus on genetics and biology related topics as you master geology and the age of the Earth, TRock. So I appreciate it. So this question comes in. Robin Webster, $2 super chat. I appreciate it. One scientific claim debunked by religion.
That's an interesting statement question there. I honestly don't know Robin Webster. I don't know what their position is, but it sounds to me like they're a skeptic. Is that fair, Donnie?
You know, I always thought Robin Webster was a creationist. Maybe I'm confused though. Robin, if you could elaborate a bit. One scientific claim. So maybe in other words, by religion, she's referring to Christianity, the religion of Christianity, or young earth creation. What is it debunked?
Well, I mean, I guess regardless of the position, there's a certain what's the word I'm looking for? That word, the way that word religion gets used like this, I think there's a problem in and of itself, because number one, this whole presentation, this whole discussion, I'm really talking about scientific physical evidence.
Okay, and TRock, it does look like, okay, so Robin Webster is an atheist who believes in evolution.
Okay, my instinct was correct. That's kind of what I thought. That sounded like something a skeptic would say.
Yeah, it did.
But if Robin was paying attention, I was using scientific evidence to make my case, not quote unquote religion. But I want to take that a step further, because this word religion is tossed around like this quite a bit. Your modern day definition of religion does not match the definition of religion in the Bible. And I'll go yet another step further and say, whatever your definition of faith is probably does not match the biblical definition of faith either. Religion in the Bible is how you react to what you believe. So if you're reacting to anything, in a sense, that is your religion. And that's the way the Bible talks about it. It's how you react. It's not some invisible thing in your head, like what you kind of are alluding to here. And so I did not discredit one scientific claim. What I discredited was the idea that you can tell time through any physical method available to you other than actually observing the events. Time has to be observed in order to measure it properly. That is a strictly philosophical position in one sense of the word, and it's scientific, because I've also pointed this out in the discussion, that any particular scientist that uses a method would really, really like to go back and observe the initial starting conditions and observe points in time along that process to validate that their equations that they wrote and their methods that they used and everything were correct. They would like to validate their own work in that way by direct observation, but it's impossible. Nobody can time travel. So no, I did not debunk one scientific claim using anybody's modern definition of religion.
Very good. As always, TRock. George Bond, $20 super chat. I appreciate the support. George, always a blessing. Giluli estimated an erosion figure of, there's the figure. So you need a figure above this rate. Anything you want to speak to there, TRock?
Yeah, George, that's kind of a good point. I think he's in reference to the question about how much new dirt do you have to add. But I may be wrong on that. But it does remind me, though, that in Australia, and I just heard this today through it was not on CMI or one of their own videos. It was through I think a church that hosted a CMI speaker, but I'd never heard this before. It's interesting. In Australia, there is actually an artesian well there, a very, very large one, and they are, much to the chagrin of the argument that that Doc Dino was trying to make, this particular well in Australia is basically deemed a resource, a non-renewable resource now. It's apparent, and I don't know a ton of details. I just heard about it today, so I didn't really come prepared to speak about it. George just reminded me of this. They've got this well, and they are treating it like basically they're going to have to lock it down and ration the water in whatever sense you want to say, but they want to control the usage of this water because they deem it to be a non-renewable resource. and it's very large, and it's in Australia.
Very good. You and George make a good team, TRock. Pseudonym, $10 super chat. I appreciate the support from everybody. You guys are the life and blood of this ministry, and the support for tonight's show. I think it turned out really good. TRock, I enjoyed your presentation, and the impromptu debates were really good too. So, okay, Pseudonym, appreciate the support. He says, I'm neutral and want to learn. At TRock, were the oceans of the global flood saltwater or freshwater? What about the waters of the deep or fountains of heaven? Where or how long for fresh water to exist, or did it? So there's a couple things there for you to work through, TRock. Go ahead.
Yeah, I'll try and be concise. The oceans of the flood, saltwater or freshwater? There's no good way for us to know definitively, but I will say that they number one, the one thing we can say with a fair amount of confidence is that they were less salty than they are today. My personal belief, as it were, is that they were probably much more akin to fresh water than they are to today's salty condition. But there's not a real good way of knowing that. What about the waters of the deep? I tend to assume that the waters of the deep were probably much more fresh as well. The fountains of heaven, I'm almost certain, would have had to have been fresh, because we're basically mostly talking about rain water cycle kind of thing that I described earlier. Is should be more of a distilling kind of process. Personally, I assume fountains of heaven basically means rain, not necessarily, I'm not opposed to it, but not necessarily water that pre-existed above a canopy or anything like that. I just assume it means primarily rain, which would be fresh water. And then he says, where or how long for fresh water to exist? Or did it? Well, obviously I'm saying yes, because one of the biblical texts I didn't bother getting into tonight gives us some really good clues to help build a flood model if you wanted to go that route. But in the, I want to say it's the second chapter of Genesis, where they talk about the rivers, the 4 rivers that come out of the garden. You're basically talking about fresh water coming up out of the ground in high volume. However big those rivers were, I don't know, but if they were rivers at all, the volume was pretty high. They weren't little trickling streams, I'll put it that way. And then the other thing that the book of Genesis tells us is that at some point in time, the author says it had not yet rained on the earth, but the ground was watered from mist that came up out of the earth. That would have been fresh water. So this question is interesting to me. I hope I answered it adequately, but one of the things that I think I understand, it's just an idea, it's a hypothesis I would put out there, is that in the early earth after creation week, the water cycle had a component to it that does not necessarily exist that way today, and that is that out in the deep ocean, the ocean floor acted like a very low movement but essentially high efficiency diaphragm. And so as the moon passed over and the waves go back and forth, you basically move this diaphragm very slowly and very small amount. There's not a huge displacement to it, but it literally pushes water up through the continent into the aquifers and up out of the ground, as is recorded in the book of Genesis. And then the water cycle, of course, puts the water that comes out of in that method, puts it right back up into the air, rains back out into the ocean, and then you can perpetuate this movement of water for a very long time. Again, much to the chagrin of Doc Dino's argument, because this is essentially one of my arguments for how creation week started out, that we had a way to make the water move more or less indefinitely. Doesn't mean it could last for 1 billion years indefinitely, and that we don't have a way of measuring the amount of time, but we had a way to do that no longer exists, at least not on a global scale like it would have back then. Nowadays we get a few very small examples of where you've got these mini aquifers that can be replenished for a period of time, but you still can't demonstrate deep time in them.
Very good. I appreciate it. Pseudonym, thanks for the support. And one final one, and we'll be wrapping it up. Looks like right at the 3-hour mark. So TRock, I know how busy you are, and so I appreciate your time for these important programs. Again, to those who may have joined us recently, TRock and we did a show going back maybe 6 months ago. I'm not sure, time flies, but you gave a really detailed presentation of your flood model. And then we did at least a few hours of open mic. So people should check that out. And Creationist Crybaby, one of your biggest fans of your flood model, has a question or objection here. So let's work through it. And then this is the last one. TRock, limestones appear in strata interleaved between strata of sandstones and other rocks. How can a single event explain all the layers? What are your thoughts, TRock?
So that's a good question. We actually covered this during the discussion with with Andrew. Me and Andrew actually kind of talked about this.
Yeah.
And I'm sitting here looking. I actually have a slide. Here it is. I found it. Donny, I'm going to share my screen for a second so I can kind of explain this, if you don't mind.
Yeah, no problem.
Um, Can you see this graphic I've got up here?
Yes.
Okay. Me and Andrew kind of talked about this a little bit. I was trying to explain to him how that some of the features that he was describing that were also described the same way in the Illinois basin, how they come to be in a flood model. And so I talked about this. This particular diagram that you see here is from it's from a particular paper, and I guess I should kind of show the reference here. It's from these websites here. A particular old Earth, I want to say he's a paleontologist, wanted to describe the Ashley phosphate beds, which are over on the coast in South Carolina, I believe. But so he's describing all this interbedding stuff and what I called lensing, this lensing idea where things kind of go thick and taper in and start anew. They go in between each layer, and the transitions, they come to an end, and then you see other layers lensing in to get a different location. And so his question is, how can you get all of this in one event? And what I was trying to describe for Andrew was that the flood account is not the account of water just filling up and then disappearing again. It's the account of slowly coming up, the waves coming in and going out. So they come in, they bring deposits with them, they go out, they create a certain amount of erosion, they come back in, so often, frequently, probably almost always from a different direction. And so that's exactly the same. And the reason I wanted to bring this particular example is because it's on the coast, and the water you see there are some lakes and stuff in that area for sure, but it's over there close to the coast. And this is exactly what you would expect in a global flood, bringing sediments in and waves coming in and going out and coming in and going out and changing directions. And because the continent is moving at the same time, you're going to get different sedimentary deposits with each new inundation cycle of a wave. I'm going to go ahead and quit sharing my screen, but I just want to point that out because it looks very much like the diagram, the schematic that I showed of the Illinois basin in the U.S., which is landlocked. The landlocked layers look just like the coastal layers, and so they're highly consistent with our idea of a global flood.
Very good, TRock. Very comprehensive. I've enjoyed this show. I'm looking forward to your upcoming debates. The Conspiracy Cats one, lots of hype for that one for sure. We had a good amount of critics in the live chat tonight, including Gutsick Gibbon making some helpful comments. And so I think your upcoming debates, I think we're going to have some good feedback for those. So TRock, I appreciate you doing this. To the audience, thank you so much for tuning in. Did you want to leave the audience with some final words, final thoughts at all, TRock?
Sure. In closing, again, thank you everybody for tuning in. Thank you for the individuals that have showed up and participated. Tolkienomics, thank you for showing up and participating. Um, yeah, so the whole topic of discussion was on the age of the Earth and is it young or old? And I've pointed out that time is not something you can measure through chemical processes or physical events or anything else. You have to have seen it happen in order to validate that any of your ideas about rates or initial conditions or anything else are real. And that's exactly what the Bible does. It provides an eyewitness direct account of events. You describe the events. You don't measure the isotope ratios and do all that stuff. You describe the events that happen. And the Bible does that. It's just that the secular community disallows that type of eyewitness event. They're happy to concede that some of the archaeological details have been found to be correct and blah blah blah, but they do not want to accept the eyewitness account of creation or of the flood. And so I wanted to put the challenge out early for those who wanted to participate in the discussion. Show me the evidence that deep time has transpired in the physical evidence we have available on the earth, and nobody can actually step up and do that. Every indicator is that very little time has passed anywhere on the planet.
Well, it's exactly why we enjoy and find it important to put on these open mic challenges where we have a guest like you, TRock, to put forth a technical presentation on a topic like this, and then give the critics and skeptics an opportunity to come in and challenge you to interact with those arguments. So TRock, you and I will be chatting, brother. I appreciate you doing this and giving us 3 hours of your time. And so I am going to let you out for the night. I hope you enjoy the rest of your weekend. I will stick around just for a couple minutes going over some announcements. So TRock,
Yeah.
God bless you, brother.
Thank you. I'm looking forward to the next debate, which I'm not sure exactly what you have the date set at now, but I think the next one is supposed to be conspiracy cats on radiometric dating. So we're still on very much a related topic at that point, right? And I'm looking forward to that. And I'm kind of glad we did not have to dig too deep into radiometric dating tonight, for the sake of the next, the actual deep dive into the subject coming up.
Save the fun for that. That's on May 9th.
May 9th.
But since Conspiracy Cats is on a totally different time zone, it's actually going to be an earlier debate than usual. So it's going to be 5:30. The last time I moderated a debate with Conspiracy Cats is going back maybe a year or so ago on Modern Day Debate. He debated Professor David McQueen. So yeah, I'm looking forward to this one. Again, May 9th. This was a sneak preview into that. And okay, TRock, God bless. Thanks for doing this. We'll allow you to get out of here. Okay, so I hope everybody enjoyed tonight's Saturday night showdown on the age of the Earth. I did want to spend a couple minutes here just going over some announcements and reminders, as we have a lot going on for you at the ministry. Doki Doki Bible Club, I appreciate that. Important playlist, helpful playlist. And so I need to make sure that that playlist is fully up to date. But if you do check that out, you can find all of TRock's past debates with us here. He's also spoken on isochron dating at our Defending Genesis conference, not 2023, but 2022. And so you can find that out. Yes, MDD, ages ago for me, in the sense that I used to debate there almost every single day. I would, well, realistically about 3 or 4 times a week when I first got into apologetics and started my ministry. So those were the good old days when I was a little more anonymous and I had the SpongeBob icon or logo. So, okay, guys, we have a lot for everybody over the next few months. If you go to the upcoming live streams section on the channel, you'll find, I think, close to about 25 events posted for everybody. I have more events as well that I'm working on, and some confirmed. I just got to get some thumbnails and get those up on the channel. And so we are going to have a summer of fun. And I'm excited for a lot of what we have. And so next week, we're going to continue the fun, as we do have a debate coming up. Let's see here. The 29th, the Great Romans 11 debate. Dr. Georges Antonios, Pastor Scott Clem. We also have on May 1st, 2-in-1, Dr. Dino and Charlie. And then we're going to open it up, open mic. But a few that I just recently booked that are going to be pretty epic showdowns. We got this one, the Great Calvinism Debate. So this one should be fun. I'm already prepared for a very lively live chat for this one, but we're going to make sure it's professional. We're going to be on top of that one. We're going to make sure it is a very professional and sophisticated debate, as I like to say. So this will be specifically on limited atonement, Sam Shamoon, Turretin Fan. This is going to be for June. Actually, we got quite a few main events for May, but also for June. So I just booked this one and also this one here. The Great Open Theism Debate, Dynamic Omniscience, Warren McGrew and Turretin Fan. So a lot of people have wanted to see this one for a while, and it is going to be happening. That's going to be in June. May, we got some epic showdowns for everybody. Steve Gregg, Phelan McFallon. I've wanted to see this one for quite a while. I'm glad that we got it in the books in terms of scheduling. So Steve Gregg, Phelan McFallon, amillennialism versus premillennialism. So the Great Millennium Debate, that is in early May. I'm also working with Steve Gregg and Bob Wilkin. So we just had Bob Wilkin here for an epic debate, I would say, on James 2 with Sean Griffin. Excellent debate. I was looking forward to that one for a while. And so now, probably in either September or October, we're going to be having Steve Gregg and Bob Wilkin debating soteriology, something to do with can a believer lose his salvation? And so that'll be a lot of fun. And in light of the fact that time seems to fly by these days, September, October will be here in no time. Speaking of soteriology, we got a good one coming up early May, I think May 3rd, if I'm not mistaken. Perseverance of the Saints, Once Saved, Always Saved, Pastor Jeff Dollar, Pastor Tommy McMurtry, duking it out in the debate octagon, a soteriology showdown. Two views or models within the eternal security camp. So that should be fun. We've also got JP Uncut and Chris Morrison. Can a believer lose his salvation? And we got some great presentations for everybody too, as I am continuing the podcast series that I've been doing. I think we've got 5 or 6 episodes. Last week, we had a solid mix of staying faithful through trials, getting through difficult times. I was here with Dr. Dino for that. We did a show on the ending of Mark and the woman caught in adultery. I did that with Will Kinney. I had Pastor Daniel from C4C Apologetics. We did a show on James 2, how to have an active faith. And so topics that are very much applicable to our lives, how to get through trials, how to overcome moments or events of suffering, how to get through difficult times, how to be faithful, how to have an active faith. And so I want to provide our audience here with topics that are really going to encourage them and motivate them in their lives. I've been talking with Helmut Welk about transitional fossils and a lot of the arguments currently being used by the evolutionary community, specifically those on YouTube. And so Helmut Welk is putting together an important presentation. I'm excited for this one. I really love this thumbnail. And evidence for evolution or creation, the fossil record. And so Helmut Welk is going to be addressing your most common so-called transitional forms. This is also in May. Dr. Jerry Bergman, The Other Side of the Scopes Monkey Trial. I've got Sal Giardina scheduled for his new series. That's up in the upcoming live stream section. That new series is going to be an important creation series for parents and students. Sal Giardina has put a lot of work into it. It's going to be at least a 3-part series. So I think we're going to do one a month. And the first one is coming up in May. And so I'm excited for that series. First week of May, we've got Young Anglican and Layman Bible Lounge. Does Acts 2:39 teach infant baptism? Got another Millennium Debate coming up. Dr. Stephen N. Whitsitt, Scott Clem, debating which view of the millennium is biblical, pre-mill versus a-mill. Another one that's up on the channel is Pastor Tommy McMurtry and Dr. William Bell. I would say two powerhouses in the world of eschatology debates and discussions. They're going to be debating first week of June, if I'm not mistaken. That is up on the channel, thumbnail, everything for people to hit that notification bell. They're going to be engaging or debating the resurrection of the dead. And so that's another exciting one for everybody. That's just a snapshot of the overall material that we have for you guys to enjoy. We just want to edify and serve. And so I just want to screen share a couple websites here. Our ministry website, stanfordministries.com. I am working on a huge update, as it's been a few months at least since we gave it a large update with all the content we've been doing. And so for those interested in just a variety of topics, looking for an answer to a certain question, looking for a debate on a certain topic, take advantage of the website. Right on the main page, you can find quite a bit of content. You can find dedication here to my brother who brought me to the truth so many years ago. So this ministry would not be possible without him, that's for sure. We've got a whole section here answering common questions and refuting arguments. I find this to be helpful because a lot of people might have the same question. And so you can just go right on the homepage. Is the behemoth of Job 40 a dinosaur? What about the flood, post-flood boundary? Do Cretaceous make testable predictions? What are Neanderthals? What about limestone? Is there evidence for Christianity? Debunking Aron Ra. Human evolution, mammal-like reptiles, pseudogenes, bacteria, distant starlight. So we've left no stone unturned over the years. And that's because of our supporters. You know, we're a listener-supported ministry. And the reason why we've been able to put out so much content on so many important topics is because of you. And so here on the main page, you can also find links to many of our books. The book here, the critic's favorite book, the Endogenous Retrovirus Handbook, my book on end times theology. I'm really hoping to one day get the sequel out to this one. There's just not enough time in the day. Special creation, updated and expanded. But go to the video section, scroll down to guests on Standing for Truth, and I have organized this in a way that I believe will be easy for people to access certain guests, and then those guest specialties, and just all kinds of topics. So for example, you know, Michael J. Ord, we'll just click him as an example, and all of his, for the most part, shows will come up that he's done with us, which are a lot. So you can get the Green River Formation, the Grand Canyon, Woolly Mammoth, flood boundaries. And so take advantage of the website. There's a lot there for you. If you go to the resources section, quite a bit there. My wife, Jessica Budinsky, she launched her new business. And so this is the website here that I highly recommend people check out. JB Natural Skincare, standing for skincare. So if you're into longevity and health and looking good forever, there is just a ton here in terms of serums, cleansers, body butters, and all made by her, healthy, the best ingredients possible. And she actually just put together a blog. And so you can have some fun going through here, and you can shop, look into this stuff. She got a great website here. I got to hire her as my website designer. So no, my website designer is great as well. And she's done an excellent job with this website. And so there's a lot that people can look at here. I'd highly recommend checking out the blog section as well, and just taking advantage of everything that we have here. And so, okay, I think we are, Mother's Day is coming up soon. And so take advantage, check that out, take advantage of the websites. And okay, I think we're going to wrap things up there. Thank you everybody for tuning in, and Standing for Truth is out.